You are listening to a piece of the Salacin.10 podcasterium. You are listening to a piece of the Salacin.10 podcasterium.
The next session will be by Mr. Marquez, which is keynote. Alright, the session will start now, and we'll take after that at 11, and then we have the tea break. Thank you. Sorry, Mr.
Bear with me, I'll get connected. Okay. Right, if you came to my talk yesterday about the relational database, I'm certainly coming to Malaysia for the last 16 years, so this is my second home. So I'm very used to conferences that hardly anybody's here when it starts. I won't take it as an affront. Okay, so when the committee asked me to do the keynote, it was like, what am I going to talk about? And I sort of went back to Sumi and said, so what's Marcus talking about? Don't know. So I said, I'll talk about why I keep coming back to Python. Because as you can see, I'm a rather old guy. So we'll see how we go, whether it fills an hour or not. So that it should really be titled this. Now I've been programming for a very, very, very long time. Half of you were not born when I started the program. Up there, these are 20 languages that I was proficient in at one point in time. Okay? When I added them up, it's about 28, but 8 of them you probably won't know anything about. Probably some of those, again, because of your age, you won't know anything about. I won't talk about all of them, but I'll talk about some of them, and once you hear I talk about them, you'll understand why I love Python. So, I'm 15 years old. I'm up in Auckland, because I'm actually a New Zealander. I'm not an Australian, I'm a New Zealander. So we have another New Zealander in the room. And I'm staying with my uncle. And my cousin, who's 2 years older than me, is enrolled at the University of Auckland. And he suggests that I should have a go at programming. And so using his timeshare account at the University of Auckland, I wrote my first basic program in using where you had a 2B pencil, and you had these cards, and you marked the card. And then what we did is we went down to the Faculty of Computer Science in Auckland, and we waited in a line, and then we fed the cards into the machine, and then you waited for a printout, which basically told you what errors you had, you got your eraser, you fixed your card, you put it back in, and then you got your printout. I cannot remember what I programmed, but that was my first experience of real programming. So that was when I was in what would have been in New Zealand as a fourth form. In the sixth form of high school, we had a computer club. And school didn't have a computer, but what New Zealand had is they had a banking interchange system. It was a consortium of banks owned this thing called DataBank. And at night, that's where all the bank transfers happen. 8-inch floppies would be taken down to the thing from the different banks, and the money changed over. They had spare computing time during the day. And so what happened is a university lecturer at Massey University came up with a version of Fortran that was called Portran, which meant portable Fortran. Again, it was a card that you marked in pencil, and you would write your program during the week, you went to the computer club, you talked about what your program was, sent your stack of cards in. When you came the next week, there was a printer. And I remember doing a program that was, because I was into space at the time, which was a missile trajectory. And I spent ages getting all the formula right, and I knew it was going to print all the things, and I saw this beautiful big stack of paper, and I was thinking, yes, it's worked. It was 200 lines of, you have an error. Fix it, you have to wait a week. So that was my initial programming. So just to give you a feel for how long ago that was. So when I did my first program, it was 1975. So I left school and I got my first job. And it was in the Navy. I was an electronics technician. And my first exposure to computers was analog computers that shot things out of the air. So I looked after the radar guidance and tracking system for the CCAT missile, which is what you see there. Pure analog. So if you do radio control, you have little servos. Basically, that's what you have with these analog computers sitting underneath the launcher, and the radar is a big servo about this big. And sitting back in the control room is a little servo about this big. And the computer, basically, as the radar tracks, it moves back, and the whole unit moves. Same thing with the 4.5-inch gun up the front. And with the Internet of Things around, you will see more servos coming back. So that was my first analog computer. But also what happened is, at the very end of my Navy career, we got a frigate from the UK, and it had a Ferranti war computer on it, which is what you see up at the top there. So it could track 255 targets. I think it had 8K of RAM. It was 24-bit. It was integrated circuits, but you could see the logic processing unit was a card like this. If a shell went through it, there was a spare card. You booted it with paper tape. And this thing, my understanding is, we're doing a bit of research last night, continued to run in the navies until about 2005. Right? But it's all about survivability. So that was my work, and also we had a PDP 1134, which was used for logistics, and I had to look after that. Was not programming it. For my home hobby, I bought a Sinclair ZX81 programming in BASIC. Again, probably none of you have experienced the joy of recording your program back to cassette tape, and then going to use it again to find that it didn't record back. And you have to sit down and key in another 250 lines. And programming was all about buying magazines from stores where the CDs had tests and basic. But the other thing that happened is, on one of the ships I was on, the Navy's only system analyst was the executive officer. And he saw something in me, and he sent me off on a Pascal programming course, and then an Ada course. Because in the military, what the programming language they use is Ada, and the reason they use that is there is, as well as a lot of compile time checking, even though it's a compiled language, there's a lot of runtime checking. Because you don't want your F-18 falling out of the sky because the computer did a blue screen of death. Okay, so sadly I never actually really got to use it in the Navy because I got offered another job and I left. And I went into a music career. I went to work for a company doing R&D, building power amplifiers for stage shows, and I was actually a roadie for a year. It was pretty cool. But at the same time at that company, they had a system for tracking all the components we use for manufacturing the amplifiers, and that was actually in Fortran. So that was my second exposure to a Fortran-based language. And probably the most exciting thing I did there was they had these big disk drives which they clipped down. And if you had a hard disk crash, because you had a fixed disk inside the unit and then you had the removable disk on the thing, it was 80 megabytes. That's big. if it crashed, you would take one of these removable ones, you would remove the platter, and then you would go in and take out the crashed dirt drive where you saw the big mark across it. You'd put the platter in, and then with the oscilloscope, you'd line up the tracks. So I was only there, because I said it was my 1 year music career. I then moved on to a company that did embedded programming for industrial control, and I spent 3 years programming in assembly. And I was very lucky. The person that taught me how to program in assembler was a guy that thought seriously about structured programming. And his assembler code, even though it's very polymer based when you see it printed out, his comments were like reading Python, believe it or not. I didn't know there was no such thing as Python then, but it got into me the whole idea of structure and how about being able to read how a program works makes it so much easier to maintain. And we had 8K of RAM and 4K of ROM. And we propelled little bits of fruit down on a machine and weighed them or optical sized them. So that was a pretty cool experience. And the other thing that I did is we had an Apple II, and I wrote some programs for doing testing and things on that. So again, if you're too young, you won't remember the horrible green screen. And for home, I bought a NEC PC 8001, 64K RAM, 300K floppy drives, and it ran an operating system called CPM, which was going to be the operating system. And then Bill Gates came along and didn't become the operating system. So one of the last things that I did when I was working at the company doing embedding, because they were a big manufacturing place, they bought some manufacturing software, and it ran on a System 36. Yep. I probably don't even need them on. No, it's fine. So yeah. I've still got London. So anyway, they bought a manufacturing system that ran on an IBM System 36, and so it was written in a programming language called RPG2, which really looked like assembly, was the best way to explain it. And when the company that I was working for was going a little bit wobbly, in the little country city that I grew up in, the only other place you'd go and work was a company called MVP Computer Services, which was a data processing group, and they used RPG2. So I got all the manuals, and I sat down one night and read them, and then next day went and sat a programming test. And got hired as an analyst programmer there. And it was around the time when System 36 became the AS400. We were going to upgrade to the AS400. We looked at the price. It was way too expensive for what we were getting. We found an environment that ran on SCO Unix that emulated that environment. And so we bought the first dual processing SCO Unix Altos box in Australasia. And we transferred all the stuff onto that with the plan that we were going to move to rewriting the software in a thing called Infomix RDS, which was a 4GL. And that's a language that it continues through. It's now called Genero, and it's probably the programming language I've spent the most time in other than Python. But at the same time, the internet happened. Right? So up until this point, my whole connectivity to the rest of the world, because as I said, I lived in a little country city in New Zealand, and New Zealand was always very disconnected from the rest of the world anyway. I had a CompuServe account. And I bought Byte magazine. That was how I kept myself up to speed. The internet came along, and it was like, for me, this big opening. And so, in our company, I had my first exposure to a dynamic website. I built a dynamic website running on NC SAHTTPD Right? So you all know Apache. What Apache means is fixing the Apache server. The Apache server was NCSA. And it was doing CGI scripts in Perl. So you see the book, it's a lie. You couldn't learn Perl in 21 days. If you're lucky, you learned Perl in 21 years. And we started with Mosaic, the Mosaic browser, and then Netscape came along the Navigator, and we had this running in all our offices. And I was saying to Dylan this morning at breakfast, the first thing we wrote was an internal focus. And then Java came along, and I think I bought another one of those in 21-day books. And it was actually a bit better than Perl. And we had a Java applet, and it was a menu. Right? Because back in those days, even Netscape with the JavaScript, you couldn't really do as much as you can do now. But when you put the applet in, we had this menu. But there was still no Python. Even though a guy called Guido had released Python 1.0, I didn't know. 1996, I finally discovered Python. Python 1.4. This is a picture of, you've all seen the picture of Guido. This is what Guido looked like in 1994. The guy there is Barry Warsaw, who again still in the thing. And the other guy is a guy called Peter Moores, who sort of dropped out of the development a while ago. So this was when Guido went to do a workshop at NCSA, the supercomputing thing, exactly where that Apache web server came from. And in the end, he went to work there, and it was sort of like a subsidiary. And then a whole lot of other things happened, and it's quite interesting. The things that I did, Guido sort of followed. Or maybe I followed Guido, I'm not quite sure. So, Python 1.4. How did I discover Python 1.4? I was using Perl. I was getting very annoyed with CPAN. Every time I wanted to do anything, I would go to download something in CPAN, because everybody tells you that's the best thing about Perl is CPAN. You would say, I need this thing, it would download, it would find a dependency, it would compile, and the whole Perl install was screwed. And so what I needed to do is we had a digital radio system, because I worked for a transport company. When the trucks delivered loads to the thing, they would come in and key the manifest number in on the radio, and it would be sent. And there was a little computer running Windows 95, which was running Paradox, which was Borland's thing to take on DBase 2. And I needed to get the data out of Paradox into Infomix. And so I had Perl running on the Windows 95 machine after probably months of screaming at it for dependencies failing in that. And the ODBC adapter was not working properly. And I was running out of days, and I was desperate, and I went hunting for ODBC things on the internet, and I found odbc.py. So then I had to learn the programming language that would allow me to use odbc.py. And I've been looking for Python in 21 days, and no such thing existed back then. And what I found is in probably 21 hours, I had what I wanted to do working. And I was hooked. And the other thing was, you go back to where I said about assembler, how the guy taught me all about structured programming. Jeremy's not here, but I'm very much like Jeremy. I'm the guy that will reformat your code. I am pedantic about structure. If it doesn't look nice, you're not a good programmer because you're not thinking about your code. So there was a language that forced people to write code the way I wanted them to write it. It is like a dream come true. So then I started to look, I want to do web stuff in Python. And I looked at CGI. And then there was this thing, and I wanted to create a structure on my web thing, and I knew how I'd been doing it in Perl. I wasn't happy with it, and I came across this thing called Botopos, which was a persistent object store in Python, and a thing called Aqueduct, which was a mechanism for writing SQL queries and tying them to database connections. And there was this, both of those were open source, and then there was this closed source web framework, and we were looking at buying that. And then, as luck would have it, they open sourced the web framework and they named it Zope. And found a little interesting quote. So in 2000, Zope was going to be Python's killer app. And it should have been. It was so far ahead of anything else back then, but it just never got traction. And because it was a slightly different paradigm that you had to think about, it didn't get traction in the whole Python community. So you've got Zope zealots like myself and Dylan, who we will say that it's moulded the way we go and do Python, or in Dylan's case, he's still using Zope because he uses Python. But also, Zope is the reason why lots of things we have in Python are there. They had a component architecture. When the ability to install things with easy install came out, Jim Filton, who was what's called the Zope Pope, the guy who originally came up with the idea of using objects and what's called a traversal for doing dynamic websites, he's split a lot of Zope out so it could be installed as products. If you use Flask or Pyramids with SQL Alchemy and you have a transaction manager, under the hood is the Zope transaction manager. So from day one with Zope, when I did anything with a database or I did anything with my object store, it was always in transaction. If I threw an exception, everything rolled back. If you go and look at all the Perl code that was out there around there, it was all very incremental, plunking its way through. So the company I work for at the moment, we still have Zope stuff sitting out there. We're slowly replacing it with Django and Pyramid, but it served us very well. And it was the first through-the-web programming language. And it could have been the PHP if everybody had looked at the original web templating language, which was called VPML. And I will admit, that's how we wrote most of our stuff, because it was fast. So CPython is actually only the reference implementation of Python. There are more Pythons. And it's interesting, I actually probably spend half my time in the alternate implementation. So as much as I love Python, and as much as we use a little bit of it in our product, and even though I am the CTO and I set the technology direction, because we program enterprise, I can't turn around and say we do everything in Python. And truthfully, we're not developing simple websites. We're developing really complex input forms, which have multiple states. We're posting tens of thousands of records in one post routine and things like that. So you end up having to use enterprise things. Right? That's what people expect. So Python's very much been, for me, a thing that you sneak in the back to do stuff. When you're using one of these enterprise frameworks and it doesn't support something that's just new, Python normally does. Probably the biggest use we have for Python is because our product runs across Windows backend through Linux, AIX, Solaris, Oracle, HP UX. We had to have a cross-platform scripting language for all the stuff that goes on in the background, and that's what Python is used for. So for a while, when I came, we used to have our Windows version of all the supporting command scripts, which were very limited, and we had all the unit shell. So Python, that was the first thing we did, was replace that. And most of our web portals back in the early time were written as well. Probably the biggest thing we achieved with CPython is, before GL we're using didn't have the ability to generate really nice printed out. It was very much as a destroy the forest type library. And so we wrote a
WYSIWYG reporting tool using a product called Report Lab, which is still going on and is really good if you want to generate PDF. We still use it. For 3 years, it generated the budget report for Malaysia. We used something else to do it. But it was one of those things, we had a problem, we couldn't solve it with our tool, there was no way we were going to rewrite something else. We stuck Python in the back end and we had a solution. My exposure to Jython came along. I've always had this thing, we had a few things in Java, and it was like, well, if we can't do it in Java, I can always do it in Jython. So where we use Jython a lot is for other reporting, because sadly Python still lacks, other than Report Lab, which is limited to PDF, a really good cross-output reporting tool. Right? There's lots of different things. You can output the Excel if you get to libraries. You can output to PDF if you have Report Lab. You can output to some printers if you go and write something in Python. If you go to Java or .NET, there are reporting libraries that basically design the report and you can output it to anything. So in Java land, it's something like Jasper reports. So that's what we do, because all our wrappers for all our Jasper reporting is all done in Java. Because we were running on Windows, I needed to make sure that we could do things in .NET. And so when Microsoft, much to my surprise, created this open source implementation of Python called IronPython, I actually was on the community development team. I think I was even MVP for a while there, but it was a really interesting experience. Now, one of the reasons why I was quite interested in this is whereby Zope should have been our Ruby on Rails, and it never was. When WHDI came out, all of a sudden we had a mechanism where people could develop a web framework that could go across things. And so I wrote the one that runs under iOS. Right? This is before IronPython. So there's an Australian guy who's written a set of extensions called the Win32 extensions, and with those I was able to write a SAPI adapter that basically implemented the WYSIWYG interface. So when we started doing our Django work, and this was way before Pyramid, we used Cherry Pie. I wanted to be able to deploy it in Windows environment exactly the same way as I wanted to be able to deploy it in my Linux. So in Linux, I was using ModWYSIWYG, and my claim to fame in ModWYSIWYG, because you'll see my name up on the website, it's not, I have written not one piece of code. So Graham Dumbledon, he and I had a conversation, and supposedly out of that conversation we had, that's where ModWYSIWYG came from. So my attribution is, I got my name on the website because of that. But the interesting thing that came along, Python came along, another guy in the US wrote a beautiful WYSIWYG adapter in .NET. And a lot of the limitations of my one just disappeared with that. Microsoft have now released that in the wild, and sadly there's a very small community that keeps going. The other thing that I play with is Pycon, so that's the Python written in Python. Never used it in production, even though I've given talks on it about is it ready for production. It's my backstop. One day, when I'm using Python and it's not fast enough, I will pull out my Pycon stick. That's the really neat thing about the environment that we're in. You see, we've got all these options. But just don't get locked in that C Python with your own knowledge. One thing we use IronPython for in one of our subsidiaries is, I remember that they had this thing where they wanted to write, they wanted to write business rules. So it was all written in C#. And they showed me this sort of form thing where they were trying to build up a thing where you had little drop downs at the end, or there were ifs, case statements, things like that. And they weren't happy with it, and the client wasn't happy with it. And I said, oh, you do realise that you're going to embed a scripting language inside .NET. And I was thinking Ruby. Because I thought we've got to write a domain-specific language. Ruby's really good at that. I personally don't like Ruby, and it's purely a bias because it looks way too much like Perl to me. Any language where the variables have to have a symbol prefix, you must be something. But, you know, I thought they're really good at writing domain-specific languages, and Ruby code where they do that, it looks beautiful. But I didn't really know that much about Ruby at the time, so I sat down with the guys and said, I'll show you what I can do in IPython. And I went back to the hotel, and the next morning I came in and they were showing me the rules engine written in IPython. So I didn't even need to actually force them down to think. And the interesting thing is, even the client does not realise that they're programming in a program. So they're only taught from the subset. And the fact that they can access all the C# objects and do things with them. So if nothing else, if your day job is that you're a .NET programmer or you're a Java programmer, install either Python or Python if you want to introspect your assemblies or your jar files. If you want to play with stuff and work out how it works, even though in the end you have to ship something in C# or Java, Python can save you. One thing about Java and .NET is it's badly documented. But get back into PyPy is Python, implemented in Python. In certain instances, it'll run 2 to 3 times faster than CPython. That certain instance it's a long-running process. And it takes a while for the just-in-time compiler to get itself working. As I said, it's my backstop. One day I will come across a thing where I have to use PyPy because I need certain speed. And there are certain websites and things around the world that's what they do. One website, I forget what it is, they were having problems with page rendering with a Python templating toolset. So they converted that part of it to PyPy, and it allowed them to basically scale up without having to actually put physical hardware into it. Since I'm old, I thought I'd better have a discussion on it. So the big thing still going on in the Python community. So I'll give you a parallel. It's 2003. I'm speaking at the first Open Source Developers Conference in Australia. So what it really should have been called was the 3P Languages Conference. So it was Perl people, PHP people, and Python people. Mainly Perl people. So this guy got up and talked about Perl 6. About it was coming. And I mean, this guy, he was number 2 to Larry Walker. So he's standing up there talking about, we will be delivering Perl 6 next year. And then he went through to show all the wonderful features of Perl 6. And the one he was most excited about is that he could create his own keywords using Unicode, and he had something written in Korean. 2004, I go back. They've got a guy talking up about the first Perl 6 interpreter, written in Haskell. Slow as anything. There is still no Perl 6. Because it doesn't need to be Perl 6. That's my bias. Not because I'm not a great fan of Perl. It's just everybody could do what they needed to do in Perl 5. The problem is if somebody comes along, they have trouble working out what the person's doing in Perl 5. And that, to me, is the problem that we have with Python 2 versus Python 3. For me, I was happy with Python 1.5.2. I didn't need Unicode. I still don't. It had the standard library, and there was some cool third-party library down there. It did everything I needed it to do. The only reason I ever kept on moving on was because something that I was using needed to go to 2.1 or 2.2. Or Red Hat moved to 2.5. And that's always the challenge when you have somebody who says, I'm going to fix my mistakes. And that's what Python 3 is. Guido felt he had made some design mistakes and he wanted to fix them. And they were not going to have the build problem. So yes, they delivered Python 3. It was slower than Python 2. And like anything, there are issues. And last year at Pycon Singapore, I probably heard the best reason why we should port our code to Python 3. And the guy who's going, I can do everything I want in Python 2.7. But if I don't think about 3, the thing that is the most important thing about Python, a community is going to fringe. And so that's why yesterday I converted, well the day before yesterday I converted all my code examples to 3. Right, and the interesting thing is I had Unicode problems. Isn't that the thing that it's supposed to fix? But that's the whole thing. The nice thing, if you really look at the changes that Guido and the team made, it's not that hard to think in 2 or think in 3. And again, it's going to, we're back in the situation is what is going to be Python 3's killer app? Because that will be the thing that pulls us over to the other one. It's not Ubuntu shipping Python 3 as its standard Python, because I'm just going to go app install Python 2.7. It's going to be because there is something there that we have to have. And that's what Curl never had. So why is it still my favourite programming language, even though I don't probably program it as much as I would like it to? So as I said, I was happy with 1.5, 1.2. I was probably happy with 1.4. Let's move on. I think Zoe would work on 1.5. I mean, some things have changed which have made it better. We have our own version of CPAN now, it's G-Shot. Not PyPy, should have never been called PyPy, it's always been called G-Shot. We have an ability to install. Yes, sometimes there are some issues with it. But at least now, a newbie can come along, and the nice thing with Python 2.7 and Python 3 now, they have an ability to install kits relatively easy. They can do what I could do in Perl, and probably 95% of the time, I won't end up in the situation I'm in. If you came to my database adapter talk yesterday, you will end up in that situation if you don't have your environment set up properly. You will have the dependency. But they're trying to solve that with wheels. Right, so that's where you can do binary distributions. I know nothing about wheels, I just know that. I have no desire to do anything. So the G-Shot was it's a really good thing. Because all of a sudden we've always had our standard library, but now Python's being used in so many more different areas, the third-party libraries have become so much more important. It's a bit like a speaker yesterday about using requests. It should replace URL lib in the standard library, but it probably never will. But because of the easy ability to install it, and because it has no other third-party dependencies, it's really easy for somebody to step up and use that. And I love requests. It's, if you read the thing on it, it's HTTP requests for everybody rather than programmers. One of the things that I still love, and I suggest you look at it, templating languages are, they're all over the place in the Python community. I mean, if I'm doing web stuff, it's Jinja 2 I use the most. But the one that we use that works the most is one called Cheetah. And it came out 1.5.1. And what it is you can define language constraints and that, and we use it as a program generator for our full GL code. So we have templates which break all the rules. There's programming logic in the templates and things like that. But it can do anything, text, XML, HTML. It is super fast because it's got compiled C++ code in it. I don't know if it's Python 3 compatible, I know it runs up to Python 2.7. That's still my go-to templating language if I need to do anything that I can't do with simple templating in Python. So that has been with me since 1999. It's my tool I always pick. As I said, we're using Django and we're using Pyramid. Because I'm a Zope guy, I prefer Pyramid over Django. All my other stuff prefer Django over Pyramid. But again, Pyramid is an attempt by some people who use Zope and do pretty amazing things with Zope to try and come up with something that gave them the flexibility that Zope gave them. And again, it's one of those things is you shouldn't lock yourself down as I'm just a Django programmer, or I'm a Pyramid programmer, or I'm a Flask programmer. You look at what your problem is, and you solve it with the right things. And sometimes Django is not a great thing. It is too opinionated. Right? It gets in the way. And I think there was a conversation going on yesterday about, with Clone, it does 95% of the things really well, and there's that 5% where you're battling with it. And that's where sometimes when you've got something like that, which is opinionated, it makes it hard for you to do it. Where you have something like Flask or Pyramid, where you can sort of go, for this one I don't have to use SQL Alchemy, I might use a MongoDB adapter, or I might, I'm just talking to a web service in the back end, so I'll be passing the picture. Right, so that's the nice thing about Python, is you can do that. So it always, when I say to somebody, so program Python, I'm a Django programmer. Be better. Not that I don't like Django, it's just that you will actually be a better Django programmer if you look at how other people are doing other things. The other thing is SQL Alchemy. I have spent my whole 30 plus years of programming looking for the thing called SQL Alchemy. For me, I finally have the perfect tool for programming on relational database. Because I've now got something that is not tied, if I program it correctly, it's not tied to the database structure and self-adapts. And I have been looking for that for years. So when it came out, it was like, if there's the library I love the most in Python, it's that. You should look at the code. It is beautiful. Look at the documentation. It's amazing. If you do any Python thing that you want to put out there in the world, use that as an example of how you should do it. Django would probably be the next one. That's why Django got such mind space. They thought about the documentation. I don't know if anybody ever used Django 0.8, which I did. It's come a long way, courtesy of the community. So let's be finished. Why? I don't think the coolest thing for me is in 1999 when I came to Malaysia and I used the word Python. I'm sure there were some probably Python programmers out there, but nobody knew what it was. It is really great that you can have a concept. For me, for what I consider as my second country, even though I live in Australia and I'm an Australian citizen now, I think of Malaysia more as my second country, and Australia probably the third. It's really great. But what we need to do is to get it out there. We need to get rid of all those PHP websites. We need to convince the government. Python is the way to go. Then this will be full. That's your mission. Okay? So I really appreciate the committee asking me to do the keynote here. Even if they hadn't asked, I would have probably put in 2 talks anyway. For me, this feels so wonderful that you guys could actually organise this conference. The thing that I will say to you, it will be easier next year. Keep the venue. Don't change the venue because it will become hard again. All those problems with Wi-Fi, issues you probably had with negotiating things, getting buses organised, all that kind of stuff, you've been through the pain. Next year's one will be the fun. And I know you guys want to do Pycon APAC. You will be able to do it. So thank you very much.
Thank you very much, Mr. Mark. We have a tea break and we'll come again at 11:30 with Let Python See Your Home at DK2. We have other session at DK1, Making Money with Python.
In terms of Jackson not keeping up with the latest version of Python, does that cause any problem with your?
I mean, it's at 2.7 and 0.8 now. Yeah, it would be when that time comes where there's that killer app for Python 3. Yes. But I think that will give the guys enough incentive to actually do the thing. But there is a branch where they are actually working down a Python 3 thing. But part of the reason why they focus so hard on 7, a lot of the stuff that they need for Python 3 they had to do in 7 anyway. And what they had to do for 7 is actually improve the performance of it quite dramatically. Startup time is still a problem, but I've run Django and Pyramid under it inside JBoss, and once it's started up, it's just as fast as if I'm running the same C Python version of it. And one of the nice things is, some of the JDBC drivers are high quality, so actually database access is pretty good. And so the interesting thing is Python is in a lot of places you don't realise. So if you do web specs, even though IBM don't really push it that hard, it is their preferred scripting language for doing the equivalent of Chef and Puppet type stuff. PureFlex, which is their big data center in a rack, all the deployment in that is written in Python. Because we're certified to run in that environment, and we had to package all our product up in that, and a lot of it is not Python. And so for us, we were like in heaven. We're sitting there, we went for the training, and the trainers were like, we're going, you don't even know what you're talking about. And we had 3 days of training. We were actually deployed within the 3 days. Oracle, if you go to Oracle, do Oracle and Python, they're starting to push it as a scripting language in their web service. So it's one of those sort of little quiet achievers in the background there. Just like JRuby is. So yeah, I'm not too worried about it at the moment. There's 3 core guys that do a lot of work on it, and if ever one of them stopped, we seem to get lucky where a company comes along and gives one of them a job. Probably where the best growth was when Sun had pretty well the whole team working there. And when Oracle came along, they all ran away. But again, somebody picked them up, and so that was the push to get to 2.7 in.
Right, any more questions?
Always catch it.
I came across the first thing that I've come across so far that only runs in Python 3 that I actually wanted, and that's Python, which is a JavaScript interpreter for Python that only runs in Python 3. So maybe that's the killer. if you want to run Python in the browser.
Yeah. No, and I think that's the thing is I do notice now that when new stuff comes out, it's more about whether the developer wants to be cross-compatible or not. And time will tell. I mean, the nice thing about it, even though I made comparisons between Perl and that, one of the quite nice things that's been about it, we never actually suffered for it. And the thing I think that was holding it back, and I think probably where there were some mistakes made, because the assumption was the community would just do the ports, is now Django and Pyramid and Last and Python 3, there's probably more of an incentive for people to actually go down that path.
I think by this time next year it'll be different.
Yeah, I think you won't have to use things like 6 and stuff like that, because in the end you will go, well, it's not a problem actually doing it, because you will also, now if we install Red Hat, in the repository we can get Python. Red Hat's always behind, but now they've got these old ones. So 3.4 looks good. Maybe the async IO will be the thing that is the other thing that really pushes Python through. But it's one of those things that gets me, because Python 2 actually had a pretty good async set of libraries as well. It's just nobody could get their head around it, and so it wasn't really used. So we all stuck with threading, and then the event came along, and we all got excited about that. But there is a library called async IO. Async and one other in the Python 2. It's been there since Python 1.5. But because Guido was really pushing it as a thing, the quite nice thing, I think it's got a lot of traction from it. The interesting thing is read the documents on async IO. I did think about putting it as a slide. Something like, the authors reserve the right to change it from a compatibility purposes or remove the library altogether. That's actually the Python 3.4 docs for async IO. So it's one of those things, is it's they're not sure whether they've got it right. Which for Guido is quite interesting, because normally when he makes a decision, he does that kind of stuff, he's normally fairly happy that all the input that he's had is the way to go. An interesting thing that I still remember is when Guido was working on the Google App Engine thing, there was a whole lot of mails on the email list, where all of a sudden you realise that Guido's not a web pro. The only thing up until that point he really knew about the web, he actually wrote a browser in Python. So it's sort of funny, we talk about having something that replaces JavaScript and Python, but a lot of the client-based HTTP stuff that's in the standard libraries, because Guido wrote a Python browser using TCL and TK. But he did have it back himself. And so, he was asking a lot of questions on the mailing list about, how was a good way, what's the sort of pattern you use when you're doing forms and things like that. And so, when App Engine came out, which again has helped Python go forward, there was Guido's little thing, which was almost his version of web.py, and it was Django. So he's sort of trying to get this little thing to do these sort of one-shots type stuff, and something that can do bigger stuff. And then now the nice thing with Google App Engine, you can pretty well, all the limitations that prevented libraries and stuff like that, you can pretty well do anything that you do on standalone or in Amazon or in the cloud, you can pop up an app. So it's one of those things where Google sort of helped it. With that, it was actually a little bit easier for me to push Python when I was talking to a client. Everybody used that Google was using it, but then of course somebody would find a thing, no, they only use it for prototype. Or it's that when I have a question, it comes up, it ends in PY on the Google side. So when App Engine came out, it was easier, even though it's a lie. You could say that, well, see, Google's using it. They don't really use it that much, but they do use it for rapid prototype.
All right. Thank you, Mr. Mark. We'll head to the lobby for the team.
I can.
Hi, my name is Shruti Sabri. This talk is going to be about project I do at work that relates to graph theory application. I just found the problem to be challenging, and it might be great to share some of our approaches and how we actually leverage Python in order to solve it. We did the project with collaboration together with the Malaysian Economic Planning Unit and the Suruhanjaya Syarikat Malaysia in order to find companies' relationship and ownership. Before I start, this is my background. My background is mostly in math. So if anything is any query in terms of the CS, please let me know. You can find me on GitHub, Twitter, email, everything is really. I'm going to divide the talk into like two parts. The first part, I'm going to explain what's the problem and how we actually approach the problem using graph theory and a little bit of linear algebra. Then you will see how I optimize the solution to make it work due to some constraint of the problem itself and some hardware limitation that we are faced with. The talk is going to be a little bit technical, but I'm going to explain everything step by step. Well, the problem is really straightforward. Given list of companies and the respective shareholders, find all companies' effective ownership. So I'll explain what is effective ownership later on. Now we have our sample data given by the SSM. Of course, this is just the sample data. So this is in tabular format. So we have information such as company, shareholders, and the share. So for example, I have here a moment. I need to show the criteria. Now, for example, okay, no mouse. Doesn't matter. So we have shareholders A basically own 50 units of shares in Full Sdn Bhd, and companies can also be owned by companies. So we have Bar Sdn Bhd owns 50 units of Full Sdn Bhd. So and the relationship goes the same as for the other companies and shareholders. If you see a relationship problem like this, most of the time you can actually solve it using some sort of graph theory application. Unless you have relationship with your girlfriend or whatever, that doesn't, of course it doesn't work, right? So tabular format is not the most intuitive way to view this kind of relationship problem. So let's use a graph to make it better. This is a graph visualization of the same data. So if you are not familiar with graph is just a set of nodes, some people call it vertices, and a set of edges. If you see all these circles, these are the nodes. So basically here, companies are represented by the nodes, and the edges is actually just the arrow. So we have a owner relationship here, and edges can have weight. So basically, the edges here, the weight are just the percentage. I mean the amount of shares that are owned by the shareholders of each company. So for example, here I have B owns 50% of Bar Sdn Bhd, and Bar Sdn Bhd owns 50% of Full. Now let us understand what effective ownership is. So effective ownership is just the effective percentage of shares owned indirectly. So maybe through a proxy or maybe through owning other companies. So what we are interested in calculating is that in the dotted line. So we have B owns Bar Sdn Bhd, and then we have Bar owns 50% of Full. So indirectly we can say that Bar actually owns Full by having some sort of shares in Bar Sdn Bhd, right? So Bar effective ownership in over Full Sdn Bhd. No, B ownership B effective ownership over Full Sdn Bhd is 25%. So how to calculate this is that we have 50% and 50%, and you got 25%, right? So it is really simple, it's really easy, and we can actually use graphical to solve this. Well, the idea is really simple. First of all, we first find all the ultimate shareholders, or what we call the root nodes. The root node just means that the nodes are not owned by anyone else. For example, here, B, C, and A here are just the root nodes. There is no arrow pointing at this node, or we can say in graph theory, the in degree of the node is 0. Basically, the in degree just tell you how many arrows pointing at it. So So in degree 0 means there is no error pointing at it. So what we do next is that for every root node, we use DFS, DFS traversal, to traverse from the root node up until the last node, and we multiply each edges. So let's see some code on how to implement this. We make use of the NetworkX package. So this one is a really good package if you are doing a lot of graph analysis. It's really complete package and well maintained. First of all, what we gotta do is that we build a directed graph. Again, if you are not familiar with graph, the difference between directed graph and undirected graph is that directed graph has direction, while the edge can only represent one-way relationship. So this works nowadays because ownership can only goes one way, right? And then what we gotta do is that we have to find out the root nodes, and then again we make use of the integrate. So basically we just iterate all the nodes in the graph and find out the nodes with the integrate 0. And we iterate all the root nodes that we found. So we use the DFS traversal here, and we multiply all the edges to get the result. So as you can see here, the result are that A ownership towards foo is 0.5, C effective ownership towards foo is 0.25. So these actually are the same with our calculation just now, manual calculation. Well, this is all nice and pretty for simple relationship, right? And it becomes a lot harder when companies own each other. So basically here we have VAR own foo 50%, and we have foo actually own VAR senior hyper 3%. So whenever this happens, we actually call the graph as having some sort of loops or cycles. And let's see if we can actually use graph traversal to make it work. We basically just use the same code, except we add some sort of cycle. I put a comment there. So we add a cycle there, and the rest of the code are pretty much the same. So this is the result. C previously, like the effective ownership of C over foo is 25%. Now we only have 16.5%. But the correct answer is slightly more than that. Why is it wrong? Now imagine this, right? Whatever profit made by foo, VAR gets 50% of it. And whatever profit made by VAR, including the 50% it takes from foo, VAR takes 30% of it. So you will have some sort of give and take relationship until there is nothing left to be split among VAR and foo, right? Good thing is that this thing can be modeled with geometric series. If you can recall from 3 or from 2, I guess, geometric series, you can actually solve this. So what we're gonna have to do is that whenever we traverse the graph and hit a cycle, instead of doing a simple multiplication, we can actually replace the multiplication with the geometric series. Now, this is easy for one cycle, but our real data has a lot of cycles, and the cycles are much more complex. So there are a lot of tracking needs to be done, and traversing complex cycles are not easy to do it right. From our runs, it took more than a week to calculate all the results. Luckily, we found another method to solve this. So we make use of graph traversal and utilizing metrics to simplify the calculation. To do this, there are only 4 simple steps. First of all, what we gotta do is that we build adjacency metrics to model complex relationship. We fit into a given equation, we calculate the inverse, and we are pretty much done with it. So the key here is the equation. And just this is not really standard model equation. This is the real equation. It's much easier to understand. So it's just I minus A, and we basically just inverse everything. So I is the identity metric, so A is the adjacency metric corresponding to the relationship of companies. So what is adjacency metric? It is just a metric that holds the weight of all the edges in the graph. Okay, so if you can recall from our previous sample, we have bar owns foo, where we have bar, the last row, bar owns foo by 0.5, and then we have B owns bar by 0.5, and others are just p with 0. So basically that's just the edge symmetry. So let's look at our Python implementation. We make use of NumPy again, NOx again. We create a diagram. This is where the diagram is quite important, because if you use under the graph here, the edge symmetries that built from it is basically totally different. And the easy part is that because we are using NOx, it's easy to convert from just the graph into edge symmetrics. We do that here, and we plug it into the equation. So then we calculate the inverse, and we get the result. Now, the nice thing here is that if you notice, there is no graph traversal done at all, right? So we do not need to care about finding all the root nodes, things like that. And even the results show all effective ownership in the graph in just one simple calculation. And it even works for cycle. No code change. The formula basically takes cache everything. However, one caveat is that metric inversion is very CPU intensive and it uses a lot of memory. Our sample data is small enough, so that the calculation can be done in a split second, but our real data is not so much. So let's look at how we can actually optimize this. Let's understand how NumPy do all the linear algebra stuff. To simplify, NumPy make use of BLAST library. So basically what BLAST does is that BLAST does all the low-level linear algebra operations, cross products, and so on, right? And a lot of these operations can actually be run in parallel, but BLAST does not actually support that. For example, if I have a CPU with 12 cores, right, running, using NumPy with BLAST, we only make use of one core. So instead of using BLAST, we use OpenBLAST. There are other options available out there, like the Intel MTL, but it's not cheap. OpenBLAST is open source. And so what we're going to do is that we just simply compile OpenBLAST and compile NumPy to make use of OpenBLAST. And here are the results. So as you can see here, we have almost 100% utilization on all 12 cores when inversing metrics. Theoretically, this should be like 11 times faster because we have additional costs. Not really right, but pretty much. We were also thinking on how to take advantage of the language point of view. Maybe utilizing multi-threading process to make it even faster, but in our case it doesn't work. Multi-thread because of the GIL. It doesn't really offer true parallelization, and since most of our bottleneck is in the CPU, then it's not IO bound. So multiprocess also does not work because of one single process already occupying all the CPUs, right? Because we make a lot of CPUs, there's one process. If we have one process, that's we are losing performance to context switching. Some of the code we wrote initially make use of recursive algorithm, and whenever we recurse, we have to make copies of our graph, and the graph is huge. So each stack frame is built with a graph object in it. So iterative is much more friendly in terms of the memory footprint. We also make use of the delete keyword. So we can free memory earlier instead of waiting for object to get waiting for object to go out of scope and before it get garbage collected. I know some of you might not agree with this approach because it's not that Pythonic to call delete keyword, but it works for us. I'll explain the code first in a bit. Well, this is the snippet of the code to test for the delete keyword, right? So the idea here is to limit the memory allocated to the process. First of all, what we do is that we create an object in memory. So you have create an numpy array of 17 meg. So basically for this process, we're actually limiting the address space at 100 meg. And we do that again. Basically, we are trying to create another numpy array with the same size. So if you don't have the delete keyword here, you're gonna have this thing. You're gonna receive a memory error because if you do not have if you do not delete m at some point, it will fail because m does not go out of scope yet, even though we don't actually make use of m at the point. So that's why we use a lot of delete keyword just to free memory earlier. Somehow, if you run this code in OS X, you are not going to receive the memory error. I don't know whether this is a bug or feature in OS X. I guess it's a feature. I don't know. Let's just assume it's a feature. We make use of NumPy to do a lot of metric inversion. So we notice that whenever we are inverting large metrics, sometimes this exception is raised. We have the SVD did not converge. The keyword here is sometimes. Sometimes it works, sometimes it doesn't. Sometimes it doesn't work, sometimes it works. So we take a look at NumPy source code, and NumPy actually, whenever they want to do SVD, whenever they want to do pseudo inverse, they're actually making use of SVD. They implemented the move on rules pseudo inverse. So basically, by looking at NumPy source code, there is hard-coded iteration limit when calculating for SVD in NumPy source code. And the limit is set to a very small number. So we experiment with that limit, and we use value that works for us. You can actually refer to the file dlm_c if you are interested in finding if you are having the same problem. This is really hard to debug. And know your data structure very well. Know when to use set necessarily. We made a mistake on using this to track our travel file. Instead of using set, we use list. So the lookup time is really linear to the size of our list. And if you do a lot of metrics with zeros in it, and you're using NumPy, this uses sparse metric versus dense. So it basically just uses sparse metric format. It saves a lot of memory because it doesn't really keep it only keeps the non-zero values instead of the zero values. Last optimization we did here is by looking at the problem from a different angle. Although with all the previous optimization time, problems are not yet solved in acceptable time. So again, we know that metric inversion, because our bottleneck here is the metric inversion. So we know that metric inversion is hard, it's memory intensive, and CPU intensive for large matrices. Probably we need to find some sort of algorithm that can run fast enough, maybe like in O1 you know to calculate, but that kind of algorithm does not exist, right? Because another thing is that the time to calculate the inverse of metric is exponential to the size of the metric itself. So if we can invent an algorithm that runs in O1, what we can do is try to limit the number of the size of the metric, right? We try to limit the m. Because metric inversion becomes slower as n becomes larger. So if we find the sweet spot for the n, then we can run it.
What do you use to inverse metric?
What's that?
What do you use to
inverse metric? We use the NumPy inverse function. Yes. I'll go over this question. So our target here is to limit the n, so we can still do the calculation in acceptable time. So if we limit the n, we can actually reduce two things. We can actually reduce the memory usage, and we can actually reduce the CPU utilization. So why is that? Well, it all depends on the A metric, right? Because the identity metrics depend on the A as well. So what we're gonna do is that we're gonna optimize the size of the metric set. So for example, let's say we have 50,000 nodes responding to 50,000 companies or shareholders. Our data is much more than that. In order just to hold the data in memory, we need at least 160 gigabytes of memory because the weight is actually float. So, and plus it is quite impossible to actually run a 50K matrix to inverse a 50K matrix. So how do we approach this? In graph theory, there is this concept called connected components. So what it does is that it splits the graph into related chunks. So the keyword here is related chunk. So meaning that if I do connect the component on the graph that contains all the companies, so I get companies that are only related to each other. So this is nice. So we can actually calculate on each one and merge back the result at the end. So this is some sample code. So instead of creating one big adjacency metric from the whole graph, so instead of calculating component 1 and component 2 together in a single matrix, what we can do is that we can actually find the connected components and then build an adjacency metric for each component and then do the calculation on that. To make this optimization even better, we can actually combine the first approach, the graph traversal approach, and the metric approach. So we can actually use normal approach for each metric component, since linear multiplication between nodes are pretty much trivial in CPU cost. And for all the cyclic nodes, we can actually approach that using metric approach and then basically combine to get the final result. Now let's look at some of the result. So in terms of memory usage, we managed to get it down roughly around 80 gig whenever we run the process, compared to the more than 120 gigs for our early trials and errors. And for the runtime calculation, we actually managed to make it run in less than 3 hours for the whole computation, versus more than a week for just graph traversal process. So here is the reference. That this is the paper that we use to actually build this model for the metric approach, and then we combine it with the graph traversal approach. And you can actually contact me at Gmail, GitHub, everything. Pretty much everything we should be is pretty much right now. And we're also hiring if you guys are interested. Yeah, that's pretty much the end of the talk. So if you guys have questions.
The complexity for matrix inversion is exponential.
Yeah.
Okay, by default, graph, when you process a graph, the algorithm can do on NQ, O on NQ.
No.
So that's
matrix inversion should be ONQ. The base case is usually ONQ.
Yeah, ONQ. I just, it's still exponential, right?
Yeah, it's exponential. Same thing, it's not exponential.
Well, because I got a friend who actually does
but it's just that ONQ the end is extremely
No.
It's no different from exponential.
No, there's a lot of different particulars. Yeah, because now there's a lot of way to actually calculate metric inverse. You can do things like LED decomposition, try to break it down. So, but the problem is that a lot of these metric decomposition requires your metric to be non-singular, which is your metric must be invertible at the first place, right? And for our case, we cannot guarantee that. So, whenever I have a singular matrix, so that's why in the code you see that instead of doing inverse, I do like pseudo inverse, because pseudo inverse basically you can still invert an invertible matrix. So I got a friend, an interesting story is I got a friend who actually worked in one of the oil and gas companies, and when we first faced with the problem, so I contacted him on how to actually do a lot of big metric conversion, right? So basically they have thousands of clusters that actually run this, while we only have one server to do this.
Okay, can I ask something?
Yeah.
Okay, question. Have you looked at GPU automatic code? Have you looked at using GPU and automatic code?
As soon as we do but we don't have access to GPU because a lot of this data that we have is very confidential. So
I mean, it's a nice, okay, that is important because they want GPU. Use Python. It might work because essentially graphic application essentially is a big matrix. A lot to get anyone. So my gut feeling tells me it's global. I could very well be wrong.
Well, the challenge is that it's not more on the inverting a large matrix. The problem is that because whenever you want to invert the matrix, you have to invert the right matrix. You can just like, if you have a big matrix, you can just you just can take some part of the graph and then invert some part of it, and then multiply the result. It doesn't work that way. So whenever you want to split the chunk, you want to split the matrix into smaller chunks, you only need to take whatever relevant. So what's that?
No, it's still
because you can only take. Yes, you can do that, but then the problem is that you only need to do the calculation based on the related companies. But we need to preserve some sort of relationship between those data. Because the data has some meaning to it. It's not just some random metric that we are trying to invert.
Alright. Okay, so I go to my second question. I foresee some sort of another way to optimize the project by distributing, because in SSM a lot of companies will be small, so the graph will be very complex. So okay, some small companies will have like at most one director, not some are not. So those are simple. So method thinkers will have a lot of that. So component with many small components, which make it very easy to distribute multiple machines.
Well, when we use the graph traversal, actually we run on 12 machines.
Okay.
That's why we got like one week plus.
Alright.
If we do it on one single machine, it takes like more than a month. Yeah, because when we first see the problem, we thought that this is going to be simple. We don't actually expect it to be this complicated. We thought, okay, we can just do a simple graph traversal, and then it doesn't work. So that's why. Another question here.
Have you tried Apache Spark in multi-instance of AWS?
No, we cannot use anything cloud because of the sensitivity of the data.
Yeah, it will be sensitive if you put the name on it, when you just send the number. We tried.
Yeah, we tried, but then we don't, because we work with the EPU and SSM. So whatever things that we want to do, we have to. There's a lot of bureaucracy simply with it, so it doesn't work. Yeah. Question?
What was the whole size of the data set? How many companies?
There's more than 1 million nodes.
1 million.
There's more than 1 million nodes.
Which is considered quite small, more than 1 million. My own company, 7 million nodes of data every day.
Oh, because my graph theory knowledge is quite limited actually, so there are things that I do not know, honestly, so you were suggesting colony, is it?
No, you can do something like visual implementation or any swarm to do the concepts. Okay? So maybe you can learn to do the English.
Well, the problem is in the traversal itself. So even if now we use like a normal DFS approach of traversing, that's also take a while, more than 2 weeks. So anything that relates to modification of the graph traversal, my thought that it's not going to work, because So we have like 1 million nodes. So let's say if you want to traverse, we have to go one by one. So in terms of the permutation, right? So we have like 2 to the power of 1 million permutation that we can use.
It's like more control on reason if you put the and then you able until it converts. So you don't have to do for all it converts. That's my.
But they already have problem with running this on multiple data set. So having that to run doesn't really solve that problem for the first place.
No, because another thing is that we have to calculate for each shareholders. So whatever we do, we still have to calculate for each million nodes. So basically, we can find all the subgraph.
Maybe which one should I turn after lunch?
You can talk to me after this to explain more about it. Yeah. Any more questions?
I turn on the Django.
Okay, thank you.
So right now we are off for lunch and then we will come back at 1:50. So at 1:50 we will have rapid prototyping with Python in this weekend. So we will have selling open source 101 in another weekend. So
now I'd like to welcome Abdul Rahman to present his talk on Django, on how Django fixed his bad Python habits. Right, thank you. And give a round of applause for him to start.
Hello. My voice isn't that good. I've been sneezing a lot today, so bear with me for a bit. Right. This is purely an experience sharing session, right, on what I faced when I first started programming in Python, and what I learned when I picked up Django after that. Right. So before that, let me start with my previous experience. So this is purely my programming experience, not my professional one. Started out using PHP. This was for a local consultancy company. Then after that, moved on to Java, and then after that, I started working in a Hollywood studio visual effects company, Rhythm and Hues. So you might have heard of it. So we got Oscar on the Life of Pi. I worked on that. My name is that, and they got bankrupt 3 seconds after that. So it was a truly sad state. So at Rhythm and Hues is when I started transitioning into Python. So Rhythm and Hues, they required us to program in Perl because that was the scripting language that we used to pass one asset to another from one stage to another, right? So I'm not sure why they finally wanted to use Python, but we all had to. We all had a big shock and were thrown into the river, and we were told to swim. So when we're doing that, one thing you need to understand about the visual effects environment is that it's all about results. It's not how you do it. It's not how beautifully you do it, or whether it's sustainable or not, because each show will be different. So they will rebuild over and over again, right? So having from Perl previous background jumping into Python, you start developing very weird things, right? You start developing habits, right? So when it comes to habits, you need to understand that bad habits are very easy to form, but they're very hard to break out of. Okay, so the underlying theme of this talk would be the importance of a foundation, and what makes a good programmer. Okay, so in this case, it would be structure, right? So the importance of data structure. When I first started up picking up Python, the emphasis on data structure coherency wasn't there, right? All we had to do, we had to convert data from one asset object to another one, right? So less emphasis was given on data structure and how to maintain it. So what happened is that we will have one module passing in a hash or JSON, we call it, right? While another one accepting arrays, okay? And another one is accepting straight text, straight text input. So what happens is that when you're used to doing that, and you suddenly change job and you're working in a company where they have specific style guide, it is very easy for you to get lost, and it's very easy for you to get reprimanded for doing something that is not proper, right? So that covers data formation, data transportation. So it is very important for you to maintain these two while you're starting to program. Because when you build these good habits, they tend to follow you wherever you go, right? So style, that's another thing. Readability and coherency. When I first started, we don't have naming conventions for variables. We don't have a proper naming convention for classes and functions. So what we did was very hacky. We tend to like monkey patch all over the place. So, but because the client doesn't see the code, right? So everything's all fine. But when you go to another company outside and try to do the same thing, then you're going to get into a lot of trouble. So even though you put documentations, you put comments, like this actual thing means this, like say X actually means, let's say name input or whatsoever, that's not good enough. Okay. Okay, so this was the biggest bad habit that I picked up, which is misusing what should be sent as an array, what should be sent as a hash, right? So what I learned, what I learned back then, there were typically no no distinction on how I should use any of that, right? But what I picked up later on in Django is because before that, right? Then there was no, I didn't learn, there was no strict way on how to handle data, because you can do anything in Python. So you can pass anything through, you can process it in any way that you want. So the biggest, I think the biggest bad thing that I did was referencing via array index. So like you're passing data to another function, but you're passing it as a list. Okay. So it ended up something like this. Right? For this example, it's pretty small. Okay, but you just imagine when you try to have, let's say there's a data set with lots of flags at ones and zeros and then other numbers. So it's very easy for you to get lost, or very easy for you to lose the meaning and misrepresent the data. Now this is common practice in the visual effects industry, right? This is a very common practice because we don't have time to think, and we were supposed to push things out the window as fast as possible, right? And this actually stuck with me for quite a while. So even when I'm programming on my own, this actually got stuck, and it's actually pretty bad practice because there's no readability on what the list actually means. So this is what should have been done, right? Where each data should be explicitly named, so you do not have to comment that, oh, this X equals to this, or X0 equals is actually the account name or whatsoever. So everything has to be explicitly done, and the name has to carry some meaning. So this is something that Django tells you to do right off the bat, right? So because of the way that Django works, it's a very highly opinionated, platform, right? So that means it has strict rules and strict structures that you need to follow to make it work, right? Because it's very easy to break stuff in Django, and they'll tell you all about it. Right. So another thing about Django is that you often have these packages, these third-party packages, because you can select what package that you want to use in your Django app. So often these packages are maintained and created by other people all around the world, and they're doing this pro bono. So So what I did before was that I tried to I tried to personally change their files if something wasn't wrong, and I know it's somewhere in their code. Instead of collaborating with them, and instead of figuring out a wraparound or not to touch their codes at all. Okay, so because in the PFX industry we tend to touch others' code a lot. So this is totally not acceptable while you're doing the Django framework. So often we need to have a common style guide, right? So this often involves communicating with the owner of the package, and working on their and putting up tickets. Putting up tickets if something that you know is wrong, and then see whether you can contribute back to them. So this is part of working with Django as well. It's not just your code that you're trying to make it work. If you know something is wrong, you have to you have to tell the owner about it and then try to work it out together so that everyone will benefit in the end. Because your use case you might discover some problem which will be beneficial for other people later on. So this takes a while. It doesn't happen overnight. It doesn't, but it's worth it. Okay, so there's another thing about Django is that everything has a place that you need to put in order to make it work. So this is also something that I did because I can't just haphazardly create my own stuff and put it in all other locations anymore. So no, skip that one. Okay, so this is just a quick primer. If you're not into Django yet and you're trying to make sense of it, so. Yep. So this is my own cheat sheet on what happened when I tried to use Django for the first time. Is that you can put stuff on the website that takes stuff from your database, but how it does it is how it does from the database to the website is through this. Like from your website, it takes arguments from context data. So the context data comes from your views, or they come from context processes, right? And in your views, they normally deal in request objects. So they get them either from the forms or from another Python file that you specify. So, and those forms come from models which in turn builds up the basic building blocks of your app. The models is the one that defines the tables and the fields that you're going to use. So ultimately, everything is controlled by settings.py. So the settings. What you can do is that you can install you can use and install packages, but more than that, these packages often they have control statements so that you can control to activate or deactivate certain features of those particular package, right? So no matter what you want to use it for, Django makes sure that the structure is the same. So which is the crux of this entire presentation. So it's either you maintain the structure or it just will not work. It'll just tell you loudly that something is failed somewhere, that something's missing. And for me, because I wasn't aware of the importance of structure, it took me a while to figure out to figure out where things went wrong. So which is why, in short, this is currently my current stand on what makes a good programmer is structure. So building structure is important, but most importantly is that having very good structure and practice in it pays off face off in the end. Yep, I think that's about it. Okay, my talk is very short because yeah, because it's mainly for beginners that think about jumping into Django, and then I thought that I could share some of the pitfalls that I had. So but halfway through what I say, going through my own slides, I discovered that the biggest problem I had was indeed structure, but which could easily go both ways. I mean, coming from Perl going into Python, so the Perl isn't known to maintain the structure very well. So when you carry the habit with the Python, it's really hard to break out of it. So that's the crux of my talk. Okay, I think that's it. Okay, thank you.
Yes. Right, thank you very much. Do you all have any questions that you want to ask? No questions? Right, okay. So the next session would actually be at 3:10. Right? Supposed to be at 3:10. And the session here would be easy contributable internationalization process. And the one in DK1 will be getting started with Pycon. So but the talk haven't started, it will start at 3:10. So if you want to listen to the talk on the other track, you might do so, and probably can come back here later.
It's kind of like a protocol buffer that's .py file. And you actually run that, and then so that holds all the generated code. And so if you look at this, it's kind of a little bit ugly, but it contains descriptors for the requests and all of the code that's needed for the particular messages that you've created. So in this case, this is just a regular, like kind of a hello world example. So if I go and look at
I wondering what does he key?
He's Google guy.
Oh.
He's going to in charge of Tokyo, Japan.
So here's the actual Hello World service that I've defined in the protocol buffers file. So so here you can see like that I've defined a service reader which just says say hello and we give it a hello request and it returns a hello reply. And each of those messages have a single string value in each of them. The hello request, so you give it a name, and the hello reply will have a message, and it'll be something like hello Ian or whatever name that you give it.
Do you have to use Java to define the protocol?
Right. So this is actually like not Java. This is just this is actually just protocol buffers, which is like its own kind of little language.
Which happens to look exactly like Java.
Right. That looks really close to Java.
Yeah. Okay. Oh, yeah.
Right. So that's what protocol buffers is like. And so once you've generated the code, you can kind of import the generated code, the package that that was generated, and then use that package to actually define the service that you're going to actually implement. And I'll kind of touch on that a little bit later, I think. Actually, why don't I just look at that right now? So the service that I wanted to create is just the Hello World service. And so let's go to Hello World here. Actually, by the way, everybody, properly license your software.
So the week here. I really have no idea what this does. What is this for? See, so I have no idea what this does.
Isn't that for the data, big data?
Maybe.
In the Google.
So here, I'm actually importing the Hello World PV2. That's the package that was generated by Protoseek. And then here, I'm actually using this create reader stub, which is actually a way of creating a stub for use as a client object. So here I'm giving it the IP address and the port number of my service that's running, and then I can use this stub to call the say hello function that was actually defined in the protocol buffers. And so here I'm giving it the hello request that was defined in the protocol buffers, and the name field that was defined there as well. And so once the response comes back, I'm just printing out the message that was returned. So as you can see, it's pretty easy to actually implement a service. It's a little bit unwieldy because like the code doesn't exactly look all that readable, but it's pretty easy to generate the code and then be able to use the service free or get all the benefits of the service itself. So I'm going to go back to the presentation. So gRPC is like a really cool way to generate these kind of services, and it's like really good for some things like the kind of microservices architecture that people often talk about. So things like software as a service, that sort of thing. So at Google we do a lot of that. So we have a lot of these services sitting around, and like whenever you request a web page, it actually goes asynchronously and hits all these RPCs to different services, and then returns an actual web page in the end. So gRPC lends itself to those type of things, but now that you have a service, you kind of want to be able to do things like scale that out. And one of the benefits of having microservices in the first place is you can scale each of those out independently. And so as a way to deploy that, we use containers at Google a lot. And so we've recently created the Kubernetes open source project to help actually manage containers or clusters of containers. So in order to explain that, I kind of want to talk a little bit about what current practice is like prior to actually using containers. So what people do a lot is they, create these create their web servers, and you have like, maybe you have your REST API there, or maybe even you have an RPC API, and you kind of scale up and down those web servers, and you have like some sort of caching layer or a database and a database layer, and the cache might be on Memcache or something like that, or Redis. Your database might be MySQL or Postgres or something like that. And then on the back end, you might have some batch processing, kind of doing one-off type of stuff. Maybe you have like an admin or something like that, a type of application that you've got running off in the background there. So this is a pretty typical kind of web application, web API kind of setup. So one of the ways that, the simplest way that you would deploy such an application is by just having all of the services together on the same machine or on a couple machines, but kind of grouping them in an ad hoc manner. And in that way, you have like you don't really have any isolation between the processes running. So your database might start taking up too much memory and starve your web servers or your cache, and you have no way of like kind of scaling that up or making that scaling that kind of architecture up. You're kind of using shared machines in a kind of ad hoc basis. And you're also kind of using the same set of common libraries, and you're really highly coupled to the OS. So each of the applications is kind of using the what happens to be installed in that particular machine. And so you can get into this situation where different types of applications require different versions of libraries or things like that. And so this can eventually turn into kind of a nightmare. So you can give yourself some isolation by running things in virtual machines, but the virtual machines are pretty inefficient. They run an entire kernel and inside each of the virtual machines, so they take a really long time to boot up and shut down and to manage. So if you're going to be scaling up your application, you can like create new VMs to like kind of scale it up, but scaling up like might not actually keep up with the actual with the increase in load that comes along with your application. So it's kind of unwieldy, and it uses a lot of resources that it doesn't necessarily need to. So that's where containers kind of come in. So containers at Google, we kind of see them as a way to bridge the infrastructure as a service idea. I guess this is the left. So on the left, you have the VM kind of infrastructure as a service model, where you have you run VMs or full Linux servers, and on the right you have the platform as a service solution. So something like App Engine or Heroku or those type of solutions where the platform is kind of given to you. And so infrastructure as a service is really great because it allows a lot of flexibility. You can run any type of application you want to on it. You can basically do whatever you want, but it's really hard to manage, and it takes a lot of work. You have to manage all the deployment scripts and setup scripts, so things like Puppet, Chef, Ansible, those type of things. And then you have to create the topology that you're going to be using and manage the scaling of the VMs and things like that. Platform as a service is the kind of the opposite end of that. It gives you a lot more agility. It's much easier to manage, because you can usually deploy, and then like with things like App Engine, you can get auto scaling almost for free by using the platform. So it's easy to scale and manage, but there's not a lot of flexibility. You have to kind of fit your application into the platform as a service's rules, like what restrictions it has. So if anybody's used App Engine or something like that, you kind of might know a lot about the restrictions that are there. But things like not being able to write to the hard disk and then have, being able to write to the hard disk, but not all of your running app instances can access that disk, because it's only on one instance. All of your other instances might be running on different machines. So there's like a lot of there's kind of an inflexibility there. But we see clusters and containers as being something that can fit in the middle of that. And so you can basically run anything, but it also gives you the ability to create deployment strategies much easier. So containers look something like this, where you have a set of libraries inside each container, and they all are running on top of the shared kernel. But they have isolation based on some kernel features like C groups and namespaces. And so starting and stopping containers is just like starting and stopping processes. It's really quick. And so you can scale your application up faster, as well as using less memory and less resources for each of those. And just as an aside, like everything at Google runs as containers, so like Gmail, web search, maps, everything. So even our VM solution runs in containers. We run KVM processes inside containers to run our VMs. And we run over 2 billion containers per week. So this is some of the reasons why we use containers. There's the benefits are numerous. So things like performance, repeatability, isolation, visibility, portability, etc. So basically, containers allow you to create a very nice packaging format that you can use to deploy. So that's where kind of Kubernetes comes in. Kubernetes is a way of managing a cluster of containers. So not just one machine, but a cluster of many machines, and then Kubernetes kind of figures out where it's actually going to run your containers. So it's kind of like a distributed scheduler for containers. It's been recently released as 1.0, and a lot of companies are kind of getting on the bandwagon to actually run it or actually help implement it and create services around it. So I'm going to kind of skim over some of these concepts, but Kubernetes has the idea of pods, which are scheduling multiple containers on a single host. Each pod gets its own IP address, so each of the pods or each of the containers inside the pod can talk to each other on a local host. So this allows you to kind of combine pods, simple pods or simple containers, simple applications to create more powerful objects. You can label those so that you can kind of create dashboards and do different kinds of selections later. Replication controllers allow you to create scalable units of pods. So basically say, like, I want to have this many pods running, and it'll schedule that number of pods, and if they crash, then it'll restart them, etc. You also have services, so those kind of like go right alongside replication controllers. So you might have our version 1 service here that has a service on top of it that has a selector for that particular label, and then provides an IP and port that you can connect to run the service. So this is actually what I'm going to use when I create the gRPC service. So you can imagine that each one of these pods has a gRPC service or its gRPC server running in it, and you just connect to the service IP to actually load balance or run it across a bunch of different pods. So I'm going to kind of demo what that looks like. So let's see. So here I've got a YAML file. This is a settings kind of file for Kubernetes. And this takes this data here and pretty much parses it and sends it almost exactly as is to the API for Kubernetes. Kubernetes has its own API that you can use to schedule or create replication controllers and pods and things like that. And so here what I'm doing is I'm setting some metadata. I'm giving my pods or my replication controller a name, telling it how many replicas I should run, and giving each of the pods a label that I can use to select later. And I'm going to use that label when I create the service. And then here I have a spec for the container itself, giving the containers a name and an image, So here, if you listed multiple containers, that would allow multiple containers within your pod, and they would be scheduled together. Here, I'm actually not going to do that. I'm just going to have one container per pod, and here I'm specifying the container port for the particular service. So Kubernetes is controlled using the kube control command, and I can do create. Run the create commands to actually just create a replication controller. And once the replication controller is created, it's just going to start up the pods that it needs to. So if I go to kube control, get pods, I should see 2 replicas. They might not be completely started up yet, but yeah, so I have 2 pods now running, and these were created by the replication controller. And so now what I'm going to do is I'm actually going to go ahead and create my service as well. So the service is created. The service looks kind of similar. So it has an you tell it which selector to use. You select which pods it accesses, and then give it a load balancer. So if I do kube control, get service. So here, doesn't have the port that PX. Still starting up a little bit. So I'm going to use that public IP when I actually connect to my service, but it's not attached yet. So here, if I go to my go to the I put in my IP address for my service. Okay, so then once I've set that IP address, I can run my greeter client, which is going to just go connect to the service. And so like you can see that it just connected, ran to say hello, and came back with hello you. So if I go here and I change the greeter client, say instead of you, say like in Malaysia, then I'll do something like this where it comes back and says Pycon Malaysia. So here it's actually connecting the server is just creating this particular message for me. So that's a really simple way of like taking a look at what gRPC can do. Obviously, he can do like some really much more complicated setups, and you can use that kind of setup to actually create a scalable service. So the replication controllers within Kubernetes can be used to can be resized, and in that way you can scale up the service once you have a lot of you actually need to manage a lot of connections. So I think that's it. Yes. Okay, so I can take a couple questions if you have some. Yeah.
How does gRPC perform in terms of streaming huge binaries and things like that? Is it?
So streaming huge binaries. So like, I don't know that it's great at streaming huge binaries. It does support streaming, so you can do things like create a streaming service that like you connect to, and then it will you can stream responses. But I don't know that it would be really great for things like streaming huge binaries or something like that. Yeah. But you can kind of stream it, stream a little bit at a time and process a little bit at a time instead, like return chunks or something like that. You can definitely do something like that. Yeah.
Okay, thank you for opening our eyes to that one.
Yeah.
It's kind of how I imagined Google would run in the back end, but
right.
Just like whoa, too big. But how can the lowly web developer just begin with this? It seems it's like a big block. And how could I ever immerse myself in it?
Well, you can kind of start one at a time. You don't have to like go all in with like gRPC and Kubernetes. You can like kind of take a look at Kubernetes and see what sort of benefits that gives you, and gRPC separately. And you don't necessarily have to like go all in both ways. You might say, well, gRPC is a little bit too complicated for me. Maybe I'll just use Kubernetes or one or the other. The idea was just to give an idea of like how you might create those kind of microservices. You might end up deciding that REST is just better for you. Yeah, last question. What is it?
Two questions. So, how does it compare to how does Kubernetes compare to Docker Swarm, and how hard is it to do auto scaling with Kubernetes?
So right now, Kubernetes is doesn't support like something like auto scaling natively. You can definitely build something on top of the API that will allow you to do that. That's something that we're really actively looking at. One of the things that we do is have some monitoring daemons that you can run inside of each of the nodes to monitor the containers, and then aggregate them, and then use that for other things like auto scaling and notifications and things like that. And as a comparison to Docker Swarm, so I can't really say too much about Docker Swarm because I'm not super familiar with it. But one of the things that Kubernetes supplies is a lot of the networking part, as well as the services. I think that there's not necessarily an analogous part to services within Docker Swarm, but I could be wrong. Yeah. So yeah, if you haven't, anybody has any other questions, you can grab me around the conference. I'll be here for the rest of the day.
Let's give Ian another round of applause.
So, can you hear me?
Yeah.
Yeah. All good?
Yeah.
Alright, cool. So, good afternoon. It's 3:15 p.m. So, good afternoon, everybody. My name is Nazro. So, today we're going to be presenting a session on getting started with Pycon, or titled Pycon for Noobs. Before that, how many people here are noobs? Yes. Because I don't want to be embarrassed in front of all the pros. Okay, so the pros are the pros, so they don't need Pycon, they need something else. So Pycon is a static site generator which is powered by Python. And I don't want to actually explain more about what Pycon is all about, but just going to tell you a little bit of a story that how I got started with it. So a little bit of background. Who am I? I work for a startup over in Singapore, sparkline.com. I'm also an organizer for the Google developer groups in Kuala Lumpur. 2 days ago, we had a session on Google Cloud Platform, and Ian was there, and a couple more of his friends. So we organize those kind of meetups, and I invite you to join us and just Google developer groups Kuala Lumpur. All right. And I've been building web software for almost now 16 years. Very much in the early days. So today, we're hoping that I'm able to actually teach you about why you should use a static site generator, and then show you a little bit of how you can actually set up Pycon, and then show you how you can generate your own first site and deploy it to the World Wide Web. So why Pycon? Okay, so this short warning, could be bad jokes ahead, right? You can boo me if you want to. So which one is the best? So you have all kinds of different CMS out there in the world, right? So you have WordPress,
Yay.
we have Django, and I personally use Flask, and also Drupal. So then again, there's so much CMS, so many things out there. Which one is the best? That's always the main big question that nobody has ever be able to answer. Yesterday I learned that Plone was a CMS that is unbreakable. Alright? I don't know. I didn't know about it. So that's not probably my next choice of using a CMS. I would want to use Plone.
You did support for it.
Okay, cool. So this is the first question. When you want to build a website, which CMS do you want to use? You got to choose which one is this one is that, right? And it's troublesome. So, but then again, those kind of CMS, it requires there's a lot of complexity. There's a lot of software plugins that you have to maintain, even different plugins. And you go like, how am I going to do this? And it's troublesome. And on top of that, it's bloated. You're also like Jabba the Hutt over here, bloat like me. Big fat piece of software. And even like you have, there's a couple of software out there where they repackage it as a distribution. It's still a piece of bloated software, right? Because you have to maintain all the other plugins that they have actually integrated into that package.
Yeah.
And security vulnerabilities. So you have to deal with those kind of concerns. You have to use it, but you use WordPress. WordPress is very exposed to cross-site scripting. You use Plone. Yeah, people say it's 100% secure. But you still have to secure the software, right? And you use Drupal, well, it's the same thing as well. So you use all kinds of CMS. Security is something that you have to think about constantly. And it's troublesome. And the most important point here is that if you're just too lazy, you don't want to be stressed out with having a website that requires all these different kind of checkpoints that you have to put in your list. You don't want to be maintaining server-side scripting software, PHP. So you don't want to be maintaining a database. You don't want to be maintaining the MySQL software itself. You have to keep upgrading all the time. And most of, in my daily work, I don't like reading other people's code. And then try to figure out what is that one particular bug that's causing this particular error. So it's troublesome, right? And if you could probably figure that, okay, I could just write my own HTML files and then hard code it, So why not hard code it, right? Why not? And all in all that you want to do is just a website. You just need a website up and running, okay? So how can you build a website using Pycon? So let's all have a 60 seconds of silence. We pray to the demo gods first, just to make sure that everything works. Okay. So first thing that you need to do is you want to set up Pycon, right? So the requirements are pretty simple. You need Python, at least 2.7. You need pip, at least 7.1 is a package manager. And you need a virtual environment, which is recommended. The version that you need is at least 13.x. So if I show you my terminal, so after installing Pycon, I won't show you how you install Pycon because it's going to take a while. You need the internet. But then again, when you want to install Pycon, please install it in a virtual environment. Okay, so right now I'm already in my virtual environment, so I can get out and I can go back in. Okay, so what having your Pycon installation in a virtual environment, what it helps you is it doesn't create some mess of other mishaps in your default environment. Okay, so it has its own container environment that doesn't mess up everything else. So like Joga says here, just keep everything in the virtual environment. Alright, so to install Pycon, it's pretty easy. So just run pip install no cache or anything for Pycon, and it installs everything. So what it installs is that number one, the feed generator. The name says by itself, it generates XML feed. Unidecode, it translates Unicode strings to ASCII strings. Markup save, it escapes Unicode characters string safely for HTML templates. Docutils, process text documentation to usable formats like HTML or XML. And docutils is primarily used together with Markdown, where we write our pages in Markdown and then it gets exported into HTML files. And then Blinker, which is an object-to-object broadcasting and signaling system. Alright, so just to show you demo, which I will not show you how you set up your Pycon. Okay, but for the sake of demonstration, you can just Alright, it says here that I've already installed Pycon, so it won't install for me. Okay, but you get a message when you start installing, you're going to see all this bunch of stuff. Alright, so next, okay, I'm going to show you how you're going to start generating your website. So we're in a clean directory. There is one command that you need to run, which is Pycon quick start. So what happens here, it generates a scaffold website. So it asks you where do you want to create your new website, basically which folder, whether it's in the current folder the program is running right now or in a different location. So I put there test folder. It says here Pycon website. Who will be author everybody. And then what language will this be? TY. And then what URL? Okay, do you want a URL specific? Yes. Okay, what's your URL? You can put your URL. The sexy pythonista.com. Okay. I don't think that domain is taken, so it's fine. And do you want to enable pagination? Obviously, yes. Then how many articles that you want to put on the page? 10. Okay. What is in time zone? Asia 4. Do you want a fat makefile? Yes, this would help with automation. Do you want to auto reload? Alright, yes. Say yes to everything. Do you want to upload your website using FTP? No. SSH? No. Dropbox? No. S3? Why there's no maybe? Okay. Rackspace? No. GitHub pages? If I can make some time. Alright, is this your personal homepage? No. Okay, so done. Okay, the new project is available in that directory. Right, cool. So in that directory, let's yes. So there is several folders, right? So in that directory, after you run Pycon quick start, you will generate 2 folders and a couple of Python files. And the main folder is the content. This is where you write your pages in Markdown. And the output folder, this is where the Pycon program will generate the HTML files and they will place the HTML files in this folder. Okay? And you don't need to worry about the other files unless you want to do some advanced implementation. Okay? So the next thing that you want to do now is actually write some content. Okay. Show you this. Right, so you have the test folder here. And then there is no content here. So I'm just going to create a new file. say hello sexy .md. MD stands for markdown. I'm just gonna copy this, put it here, and this is sexy. Okay, the title hello sexy Pythonista. Right? And for the sake of just having an extra page, create another file, I'm just gonna say that Mamacita Pythonista, Mamacita.md, alright? And just gonna say this. I am the mother of the sexy Pythonista. Pythonista. Right, so I have two files, two markdown files. So what I'm going to do now, I'm just going to generate my Python site. Okay, so the command to run that is Pelican content. And content is referring to the folder that you want Pelican to read the markdown files. Right. Boom. Okay, it says it processed 2 articles, done in less than a second. So if we look into that folder, so they'll generate a couple of folders and also a couple of more than one HTML files. So let's say you want to see this running on your local machine. Right, so there's a default command that you can run to start up the HTTP server for that folder. Right, then you go to localhost 800 and boom, you can see your website. So in less than 10 minutes, I have my first Pelican website. Alright, it works, it looks like a blog, it has different pages, it has category pages, it has author pages, and stuff and whatnot, right? So you pretty much built your first website using Pelican, and it's all running HTML without any kind of database setup, need to be set up, and you can get it up and running quickly. So next would be after you have your site set up, okay, the next thing that you want to do is to actually deploy it to the World Wide Web. So on the internet, you can actually deploy your static HTML pages to several locations. There is Dropbox, there's Rackspace cloud files, S3, GitHub pages, and these are the prompts that Pelican program asks whether you want to install it to these services. The missing services that is not in the Pelican startup script is Google Cloud Storage, the blue guy here, okay, and App Engine. So you can actually use App Engine as your hosting for your Pelican generated website. Alright? And I'm going to show you how you can do that. So first things first, let's sit down. Okay, so first things first, you have your Google Cloud dashboard, right? And obviously you have to create your own project, and when you create your own project, you go through that process and blah 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 blah. You get to see the App Engine portion over here, and over here you can see the dashboard. Alright, and you can see how many requests were made in a particular period of time. And not only that, to make this happen, you also must have the Google Cloud SDK installed. So Google Cloud SDK provides several command lines that is useful for you. So gcloud There's default commands, authorization commands, beta components. It also helps you manage your compute engine instances and whatnot. Right? So have this installed and also have a Google Cloud platform account. Great. So the first thing that you need to do to create a website using App Engine is to actually create an app YAML file. So in this test folder, you create the app YAML file in the output folder, app.yaml. And for the sake of speed, I'm just going to paste. So over here you can see you declare the runtime, the API version, and you make it thread safe. And also notice that the handlers in the app YAML file are URL theme, static directory theme. So this refers to this folder, which contains the CSS and also images. The author folder is here, and category folder is also here. So this is pretty much not the best way to do it, but this is just me being lazy, so I just want to get things done quick. Because the only thing that's missing is that it won't actually serve a 404 page. And I have general URL handler that takes all other requests and then sends it over to the main PY file. So then, and also I declare a couple of libraries that I want to get I want to have it installed or included in this application. Then I just create my Python script, which is main.py. So it is also in the output folder. Again, for the sake of speed, copy, paste. So if you go through line by line, so over here you're importing all the necessary libraries, Jinja, Web2, logging for logging. And then you declare Jinja environment constant, then this is your class, you take in the request directly to the get handler, and then what it does here is basically it strips out the slash in the beginning of the URL. And then if it's empty, that's the default one, and then you try to actually run the template. And if there's any error to that execution, just give it a form, the default error template, and give it the standard form, HTTP error. And over here, it's basically to run the Web2 instance, right? So you have these two files set up for you. Okay, and then all that you want to do now is to actually run it. So you have your G-Cloud. G-Cloud, if you have run, yeah. So the App Engine command for Google Cloud SDK is still under review, but it works. Okay, so it runs, it starts up all the necessary services to run Google Cloud, SDK. We go back to the site, and boom. Alright, so we have the website live on App Engine. And again, this is not sexy, it's just your local development machine. So what you really want to do is to actually deploy out App Engine. So in App Engine, you have your project name, which is very critical before you deploy. You need to remember that. And most importantly, well, actually, you don't need to do that anymore. So you check whether your Google Cloud is set up according to the project properly. Google Cloud this. You can see here is attached to my account. The project name is KNBooks 779. So it's all set up nicely. And if you go to that project.appspot.com, oh, see something here, right? So show something. So this was a previous version that I created for writing the slides. So we have this page, and right now what you're going to look forward to is the new website. This has a different inline here. Okay. So what I'm going to do now is to deploy the website and run it. G-Cloud SDK is taking its own sweet time to deploy to the site. Alright, it's done. Okay, so it says here that the site is now deployed to this particular URL. Right? Copy, and let's go and see the website. Oh, it's done. It's all live. Okay. And it works as expected. And it's all HTML static files. So then again, you actually want to have it put it up here as part of the main domain, subdomain. Okay. So you go back to your app engine, you dashboard, and then you go to the version dashboard, version menu. Click on it, and then you can see this list of version that has been deployed to your App Engine instance. So this is the latest one, which was deployed 0 minutes ago. And I'll just click here and make it as default. Oh wait, before you actually clicking default, you better make sure that this is what you want to see. This is the version that you want to publish. Okay, everything's cool, done. And yes, you put it to default. And when you go to the main subdomain, the website is now live. So all that done in less than 1 hour using Pycon and App Engine. Right? So how cool is that? Okay, so next, there are other Python static site generators that you can actually try. We have Nicola, we have Hive, and the comments that is out there on the internet is that Nicola is slightly more complex, Hive is okay as well, and they also have a very large community behind it. And I recommend you to read these links if you want for more reference. These are different links that you can read about creating static sites and using Fabric for automation. And also, if you're coming from the WordPress background and you want to actually use Python for your site generator, you can read the articles. And a bonus read, you can also read an article on how to host a static website on Google Cloud Storage. So they have a similar service like Amazon S3. You can create a bucket, put your HTML files into those buckets, and then set up the custom domain name, and then you can serve those pages. And not only that, I also encourage you to go and check out the Google Developer Launchpad program, where they have programs for startups and projects, and the cool stuff about it is you can get free credits and loads of other stuff as well. Okay, so do you have any questions? Any questions? Yes?
Let's say my data is all in database right now, so can I generate static site using it?
Yes, you can. You must first export that data into a readable format that the Python program can read. You can create like a script just to export those pages out into a markdown file or into an XML, and then you run the Python program to actually auto-generate those HTML files. So you must export the data out first, then only you can actually generate your static site. Any other questions? Go ahead. Alright, cool. So keep in touch. You can email me if you want the slides. If you want to see the slides online, it's also available at my website, nazo.com. Alright, cool. Alright, thank you very much.
Thank you, Dr. Kamarudin, for this session. So, what's next? Second-day closing and a photo session at PK2. So, actually, that session will start at 3:50, so you guys can sit here and chit-chat around, or you want to move there, your call.
Yeah, if you want stickers, you can come and pick it up over here.
Can you guys hear me? Actually, we don't need this mic, right? So, good afternoon, once again to all of you. I hope you guys enjoyed the footage now. So, once again, I'm going to be your MC for this session onwards. So, without much further ado, let's get started. This session is going to be rapid prototyping with Python by Rennie 4. Let's put our hands together. Thank you. You guys hear me?
Yeah.
Thanks. Okay, so rapid prototyping. Right. So first I'm going to start off with a little corporate duty. So who am I? I'm the co-founder of this adventure studio. So basically we build education games. Some of our backend stuff we use Python here and there. And I'm also the co-founder of Pixel. We use Python everywhere here. So we are building a cloud-based management system. Okay, now the boring stuff is done. So let's start with what's prototyping. Okay, on Wikipedia. So a prototype is an early example of a model, of something that you don't build, something that you don't test your idea. So prototype also means primitive form of it. So basically it's your first iteration and your first form or whatever you want to do. So this is prototyping. So what does prototyping mean? Does anyone know? So basically just do it faster. Prototyping. Okay, so why is prototyping important? So prototyping is important because you can fail early and fail cheaper. So basically a prototype is something that you just build to test your ideas to see if it works. If it doesn't work, then you just try again, right? Then of course, proof of concept. Especially for startup founders, sometimes you think your idea might be good. You know, so before throwing in the full resources to try your idea, you might want to build a prototype to test the idea and to gather the real requirements. Are people really looking for this? If not, what are they really looking for, right? So communications, especially startups. Whenever you start up an idea or a business, you will form a new team. You know, sometimes you may not have the core people that you need, or sometimes you have maybe new people. So it's got a good time to test your communication and your team capabilities, like whether they are good enough or not, or you need to find someone else, right? So finally, you might want to produce your MVP. So a lot of times, startups, you may not have enough funding to go all the way. So you might just want to come up with something cheap to prove your idea, to prove a concept, to talk to people like VCs, or maybe even to form your core team. You know, you're a business founder, you need a programmer, you're a programmer, you need a business founder, right? So an MVP is ideal. So prototyping is good for all these things. Okay, so why Python for prototyping? Because Python is easy to do. A lot of universities, schools and stuff, they're starting to switch programming to Python instead of the more core languages like C++ and Java. Of course, Python is focused on development speed. You can ask any Python programmer here. So they focus a lot on syntax, simplicity, clarity, so it's mainly on the programmer side of things, not really technical speed, right? So it's very, very good for prototyping. And of course, Python is a very expensive standard library. So a lot of times the standard library is good enough just to prove the concept. You don't have to go for the best or something that you might need to spend more time on. And of course, if the standard library fails you, then the package index will thank you. And of course, if that fails, you can actually go to other languages as well. Python is quite flexible in this case. To realize almost every library out there, C++, Java, you have a Python wrapper somewhere there. Yeah, which is why Python is awesome for other languages as well. So, enough with the talk. Let's start with the real the prototype. So we're trying to create an eShop in a REST API and a mobile app. So basically, whenever you have a startup idea, this is the first thing you need to create a website. Let's say an eShop. And then of course you will need REST, which will talk about the services, other services find it talk with you. And then of course, as a bonus, you might need a mobile app. So we can actually get this done pretty quickly with other technologies. So for the web framework, my choice of web framework is Django. It's just a basic preference, so you can use anyone you want. And of course, the REST API will be one for Django. Okay, for the mobile app, I'm trying to use Kiwi. So for those of you who haven't heard of Kiwi before, Kiwi is actually a very awesome Python project. So basically, it's a cross-platform Python NUI development. So NUI stands for Natural User Interface, basically touch now. Right? Okay, so what Django? Because Django is Python. Okay, so basically anything that works with Python technically should work with Django. And Django is also both Python 2 and Python 3 compatible, so you may not have to worry about language that much. Django is open source, so it works well with open source technologies that you really like, things like engines, Redis, And then ORM. Okay, there's a star there because this is subject to debate. Some people like it, some people don't. But ORM is very good for programming. So auto admin, another good thing about Django is that it creates the auto admin panel for you. So you got the CRDB handle. And of course, the latest version of Django 1.8, we have schema migrations as well. So you really don't touch the database if you don't really need to. Right? Kiwi. Why Kiwi? So Kiwi is also Python, and most Python libraries look at each other. Kiwi language. So Kiwi has its own language similar to Nokia's QML. For those that still remember Nokia, it's a phone. So it used to be awesome. Everyone tried to develop in Nokia, so they come up with this QML language. So basically, it's a CSS for mobile app. Just think of it that way. So Kiwi is the Python version of that. We may not be touching on Kiwi in English this session, but yeah, Kiwi should be an episode standard session, so I'm just going to go through it very, very quickly. And yes, Kiwi supports OpenGLES. It can be gained, recommended or not, that's up to you, but can be gained because it's fast enough. Cross-platform. Kiwi built with Python, so anyway the Python technically runs Kiwi, but they have IDE for Linux, Windows, and Mac, so which is very good. And the best thing is that they have this automate build. So basically, if you have the correct requirements, you can actually deploy it on both iOS and Android in one code base. So this is actually one of the main reasons that I like to prototype Kiwi. It doesn't need to be the fastest or the best, but it just works everywhere for you. That's your idea, right? And plus point is that you can also deploy it on things like even desktop, like Windows, the latest one which supports touchscreen. It's also support because the code base is generated there and it supports touchscreen. So that's actually the power of Kiwi. Right. So we got a lot to do. So let's actually start. Right. So let's start off with a simple Django project. Okay, so let's see. Is that it? Okay. First, let's check our requirements. So we need the basic Django apps, Kilo, and we can type that. Yeah. Right. Okay, so first requirement that we need will be Python, Kilo, sorry. So it's the de facto standard for Python as an implementing library. Of course, we need Django itself and the REST framework. And then we have the documentation for the REST framework, which is pretty awesome that I'll show later. So let's start off with creating a new project. Start project. Let's call it shop. Okay, so once we have a shop, let's run similarly. Yes. Okay, so we start our project. Let's check this run. Please. Okay, works. So the second thing to test will be the admin panel. Because Django actually comes with an admin panel. Yeah, so you are done in practically 20 seconds. Right, and there's more to it. Even all the settings and control config panels, everything is already done already. So you don't really have to code anything up until now. Right? Okay, so now that we confirm that our website is working, now it's time to build our real website. Okay, let's put that here. Okay, this may not be the best practice, but I'm just doing this because it's easier. So let's create a models file here. So models basically is where you store your ORM codes. Okay, to save a little bit time, I should follow take some codes, so hope you guys don't mind. Right. So basically a model is just a class inherited from the class called model. Right? So if you call our model product, the attributes there, name, description, and image. Right? So as most Django users know, the most important thing to do after you add your model is to create your migrations so that the database, your project will remember all your database schema. So to do that, go back to the root. There's make migrations short. Oh, wait, before that, we have to add this to the settings. So, yeah. So the default settings is pretty good for prototyping, but you have to add a few stuff now. So the first thing that you may need to add will be your own app under install apps. So let's add our shop. Then you can make migrations. Okay, so for the older Django users, you will realize that the syntax is a little bit different. This is the one that is built into Django, not the third-party sub-package. Right, so after you make the migrations, you just need to migrate the database.
Wow.
And it's done. Okay. So after you got your model, the next thing that we need to do is to add checks and add stuff to your models. So Django has another awesome feature called auto-admin. So all you need to do is to add an admin file to it. So let's do the same thing. Okay, so basically what this file does is that it tells Django to register this model into the admin, and somehow Django will do the rest. So let's see what Django does. Okay, so the main page still looks the same because we haven't done anything to the views yet. But if you notice here, the administration, the product is automatically added here. And this is one of the best features of Django, and it's very, very good for prototyping. So you can directly add your new products here. Product 1, and you're almost done with your UI prototyping. Let's say, yeah, this is a very cool widget to add instant to your designs. So let's say product 2. Yeah, so you may not even need a UI for data entry. So maybe on the back. Right, and of course it also supports pictures because we already did that. This is one thing that I want to show you here. Okay, Django users will notice that I didn't set a media URL, right? So if I save this, it should fail. Somehow it works. Right? I'm going to come back to this later to remind me auto. Okay, so now that we have our models, we can add our model. So what do we need? We need to show it on the screen, HTML side. Right, so in Django MVC, so the next thing will be add model, V will be the views, right? So, sorry, I want to take code again. Okay, so here I choose to use okay, I promise. I'm not sure I didn't tell my guy. So, okay, so here I decided to use class-based view. So basically I just use the English view, inherit it, and I set the product, the model to product, and of course the template name to home. Okay? So the next thing will be to route it. So unlike Flask in Django, you have to set your own URLs. So over here, you can see that Django already automatically added the admin URL, which is why you can see the admin over there. So to set our home, this is technically the home number. Right, but shop still home, right? Since we are using class-based views, we have to do a little bit extra code here. So we have to import our home view, which is a class instead of a method. And replace this with the class as view. Right. So if everything goes according to plan, this should show in the first page. Let's try. Okay, so everything works except that we didn't create a HTML file, right? So let's go do that now. So by default, all Django templates should be stored under a folder called templates. And Django will know it because it's tabular. So under templates, you just need to add your file there. Okay, let's test this first. Let's call this home HTML.
Placeholders.
Okay, let's see if Django can find this. Okay, so Django found it. Okay, so one of the reasons we use class-based view is that because there's a lot of boilerplate stuff. So one of the cool stuff that is boilerplated is a list of objects. So if you use the template language over here for object in object list, so object list is automatically passed into this template by the class-based view. So, okay, for those that are not familiar with Django, basically the one with the % sign is a method. The one with the double bracer is a variable. Okay, so when we loop it here, we use put the variable into here, right? So, okay, so Django found the products, right? So one more thing that we can test is that we know the properties of the models, right? We have the name, description, and image. So how does it come up? Okay, so we can actually do the same thing. Okay, so we basically have our very basic website with all the data here without much coding. Okay, so let's make this nicer. I should have some
bootstrap.
Okay,
bootstrap.
So it's nothing new. So by default, not to say by default, as good practice, it's good to keep a base template so that you don't have to keep on coding the same header and same filter again. Okay? So what we do with the home now is that we use the block complex over here. My screen is still a bit. Okay, so what this does is that it inherits the base template from base.html, and then it only overwrites the content on the block content. Right, so if you notice the base here is basically simple HTML except that there's a block here. So basically you are just injecting the codes to the media there, so you don't have to have complicated HTML codes everywhere. It's one of the, yeah. So as you can see, we are doing the same thing. We loop the product list, or actually this is called the object list. Okay, so we loop the object list, then we get the products, product name, product image. So if it exists, we show the image. If not, we don't show. Then description, right? So now it should look more like a shop. Okay, almost there. So the thing that I missed was CSS. So in Django also automatically handles static files for you. So how do you handle static files is that you should just create a folder called static. So as you can see, both the static and templates are magic folders. Django will know what to do with them. So try not to name your projects or your applications static or templates. Yeah, you have a lot of headaches after this. So by default, I like to put my CSS files inside the CSS folder. Okay, let's call this shop.css. Then it should look much better now. Oops, I think it's not good. Oh, okay, this is the part where we need to update the media URL. So notice that the CSS is not loaded because we cannot find the media URL file if you inspect it over here. Right, it's a 404 because they can't find the CSS file, right? So the thing that we missed to do was to update the media URL. So, okay, the media URL. So by default, Django doesn't set the media URL because Django is a web framework and not all projects need this. So they kind of leave it up on the default. So what I like to do is to call my media URL media just to differentiate it from the static URL, CSS, and JavaScript. And then I use the base directory. This is only good for local development. If you want to really deploy this with this, right? So they will show you how to deploy the static style properly to CDNs and S3 and things like that, right? So for local development, it's surface to just skip into your project base directory. So once this is done, let's check our CSS again. Okay, this time it's loaded, right? But notice that the product image is not loaded, it's still 404 here, because we didn't set the media URL before we upload the file. Okay, so to fix this, we just have to re-upload the file again.
Oh.
Save it, and there it should show. I did. Oh, okay. No need to restart the server because this is a server-side setting. The CSS is fine because it's a static file, but this is a hyper thing, so we'll restart it. Okay, so let's upload again. So oops, that makes sense. I can fix this. And you guys get this all the time to remember it.
Yeah. Handlebars.
Sorry?
It looks like handlebars. Cool placeholders.
Okay, I guess we'll get back to this later. So basically the problem is that the media URL, something is wrong. And then the uploading part or the CSS part, or something the HTML part. So, okay, so suffice to say, with a few lines of code, you really get almost fully working template. So if you are, let's say, a UI designer, this will be very good for you to start designing without very much about codes. Right, when you really need to get hardcore things done, things like shopping carts and payment method, that's where you need to build programs. Otherwise, you can just do this pretty much by yourself. And I think it's also pretty good for, let's say, start founders. You can actually prototype your ideas and your designs without talking to designers. Because a lot of times when you verbally talk and you draw it, it may not be what you want, or then it's misunderstood it. Okay, so this is for the web interface. So basically, right now we have an online web catalog that's just waiting for design. So the next thing that we might want to do is to add REST services, REST API to it. So how difficult can this be? So one of the things that we need to do is to add these two applications, the REST and REST Swagger that we added earlier. Right. Okay, let's add this there. And then the next thing we want to add will be API codes, right? Let's call this API. So basically what we need to do here with the REST framework is that we need to set the serializers and also the view sets. So basically what the serializer do is that you take the Django border and convert it into some sort of JSON format that JSON will understand. And view set is like the views. So for this view set, I decided to only make it a read-only model. Basically you can't change it, you can't delete it, it's just a read-only model, which is good enough for a prototype. And set the class of serializer, how you want to serialize your data. So one of the reasons why we have these two steps is that serializers, sometimes you might want different outputs. Some people might want JSON, some might want YML, right? So you're going to rewrite all these codes. So you can just pass in a different serializer. And of course, we set the query sets. For now, we just return all the products. Okay. The next thing that we need to do will be to add the URLs for the API, which is another few lines of code over here. Oh, that was wrong. We do not add the media URLs. Okay, so I'll just do this together. Okay, so basically for the REST API, we just need to add a router. Basically what the router does is that when in REST, we have a few methods, put, get, and all those. So what the router does is that it will just map all the URL for you instead of you typing it line by line. Okay, so use a router over here, and you just map it through the product you set. So we just need to add 2 lines of URL. One is for the documentations, and one is for the router. Okay, so basically you have your API done already. And for the mistake that I did just now, the media URL was that I did not add the serving part over here. The reason is that Django needs to know that it needs to serve by itself. Because most of the time you will use the static file serving to things like S3 or Nginx, or however you want to push your files. You know? So locally for development wise, we have to tell Django that we need you to serve this too, right? So let's go back to start this one. Okay. So as you can see with the URL, you can find the show. So the next thing that we have, Django. So first it gives you auto admin, and right now, magic, we have auto API, right? So basically this is the list API. So if you drill down, this will be exactly what you're going to pass to your client. Okay, and this is of course the web version. So how this works is that yeah, I'll talk about this later. But basically, you get an automatic API over here. So for now, we only have the read only. Read only, that means we only allow methods that is get 8 options. Basically, you cannot update this model. Alright? And also remember that we have a documentation as well. So imagine you want to pass this API to, let's say, your third party or your partners, right? And you just refer them to the docs, which is Swagger. So basically, what Swagger does is that it helps you to convert the REST framework's API into some sort of readable, documented API document. Right. So over here, they are already break it down to 2. So basically, this is the list view and this is the detail view. So if you need to get a list of products, you use this. So if you need to get a detailed product by PK, you might want to use this. Okay. So all the information are here, enough for your partner developers to develop. You don't have to go through the codes, correct? So you can even try it over here. They have a REST client over here. So once you click, this will be the sample response in JSON. Alright, so if this has something wrong, means your code has something wrong. So if this works, technically your other side should work. Alright, so once you have your API, what's the next thing that you need? That's going to be a mobile app, right? Because we don't have to build all the database and products of all again. We have it in our website. A bit early, let's slow down. This is faster than I thought. Yeah, very fast, right?
Yeah.
Too rapid.
Very
okay, so as you can see, right, within the last 10 minutes, right, we already built a website, fully working administration. You can add products, you can add pictures, and now we have a working API already, right? So now we are diving into mobile apps. Okay, so the mobiles that we'll be using is Kiwi, and if you are using Windows or Linux, right? Okay, so if you're using Windows or Linux, the best way to install is to click hit install. But for some reason, it doesn't work on Mac, so we have to manually install it on the website. So the cool thing is that you can get Kiwi anyway. So basically, just run Kiwi, the main file. Okay, as you can see, right, the product that we added just now is already here. Oh, sorry, long screen. Okay, it looks a bit ugly because the default widgets are not nice, but imagine this is a mobile phone, right? So we got our shop title here, we got our products, and then we got our description over here. And I can show you the code later, but it's mainly UI codes. There's no backend codes written. So all these are we got it from the JSON from the website. So it's the same picture and the same product, right? So you can add your own buy button here. So it doesn't have to work because we're just prototyping, right? Oh yeah, one more tip for prototyping, right? Push it as ugly as possible so they can focus on the product. You know, because some products like they look pretty but they don't look that well. Okay, so let's look at the code for this. Kiwi is a pretty complex project. The main reason is that because it focuses on a lot of widgets and UIs. And a UI for multiple platforms is very hard to do, right? If you have done Android development before, you will see that first few iterations actually look something like this, the widget sets. Right, so of course there are other plugins that you can actually make it nicer, but to save time for presentation, I'll just use the default widgets so that you can see how it's all laid out. Okay, let's go to the code. As you can see, right, the code for the mobile is only one file. and 3 classes, 4 classes. Okay, I'll go through this data. So basically, this is like a normal Python file with all the key imports. So first we start the header and the footer. Just call it the grid layout. Then this is the content. So basically, I split the app into 3 parts, right? So over here, we create another layout and we just add the 3 layouts into this main layout. Okay. So how it looks like will be something like this. So this will be the header, this will be the content, and this is actually the footer. Alright, with just a few lines of code. Very awesome, right? Especially with Python. Okay. So this is where you create your app with the 3 layouts. So let's drill down a bit. So you can actually read about all these grid layouts and widget sets on the website. There's a very detailed documentation. I'm not going to go through it one by one, but just going to go through whatever we're using. So what I did here was that I inherit the grid layout, set the column to 1. So basically I add 1 column to 1. So everything added will be going to the bottom, not to the top. And I add a label over there, which is called my shop. Okay. So this my shop label is this my shop label. Right? Simple enough, right? So there's a header. So a simple footer, same thing, just added a little something minute. So here is your footer. Okay. So the interesting part will be the Ajax call part, which is the content part. So how do we do the Ajax call? So on success is basically the callback. Okay, we'll come back to the callback later. So I set this grid layout into 5 columns. We'll come back to that later. So basically the API call is just 1 line. Okay, so basically you just pass in the URL, which you already got from your API over here. You can just copy and paste over here. And then set the content type to application JSON. This is important because if you because of the way that Django REST handles the web client for developers like us. So if you see, like, they are actually calling the same URL. It's just that the content type is different because the return is different. This one you get the right interface, and the other one you just get the result. So it's so automated, you don't have to code this by yourself to see the results of your API. Which is another reason why I like it.
Nice.
Okay, so basically what I did here was that I just do a request URL, and on success, just return it until I didn't handle it yet. So on success, basically you just return the result. Okay? So if you want to see the result, it's basically just a JSON text. JSON dictionary in the list. So you set the result to the product list and you loop it, and basically you get everything the same as your model, ID, name, description, right? So after that, it's just a matter of adding the labels, then label, then image. So okay, this is another tool widget from TV. So basically, what it does here is that it downloads the image for you. You don't even have to do it yourself. Right, so there's no code for downloading images. So you asynchronously get the image and stretch it, and then you will just show it on the widget if it's available. If not, you will just show the result image over here. Then this is the dummy final button that I added. So it's very critical. I think you can just add the button and don't do anything to it. And let the programmers handle the rest of the codes. Right. So once you add all this widget, and once you show it, so basically this is what you get. So basically you get a PK, the model name, the border description, the picture, and the dummy button. Right. So in less than 50 minutes, we have the website, API calls, and the mobile app. And I think I'm early and we are almost done. Right. Let me see if I got any more things on the side. Oh, that's not. We are done. This is too rapid. Slow it down to first. Okay, there's any questions? Yeah.
I know a large user compared to Django, but let's say if you're using things like Power, how do you actually, because I see that all these settings folder that you have is basically inside the smaller apps.
Yeah, thank you for the question. So basically the question is how to use Power in Django. Basically like what Apple always said, there's an app for that. So search for Django Power. There is someone who needs something to move the Power files into the app. So basically I think by default we use Django compressor if I'm not mistaken. So basically we compress it ourselves using Power. First there are apps for it. So there are also apps for Angular and backbone integration. Yeah, so there's a lot of things done on the packaging side. So I'm mainly focusing on the Python side. So even on the packaging side itself is a huge topic for Django. You can do a lot of things with it. Yeah. Okay, any more questions?
Let's talk more about TV and in terms of music production.
Oh, TV. Okay. TV. Actually, one of the reasons that TV was developed was for MUI interfaces last time, touchscreen devices on the touchscreen. And then recently, I think with the GDS integration with Android, they can actually access the Android's native OpenGL, which means it's good enough to build games, right? And then since Kiwi is Python, and we have a very popular game building module called Pygames, so a lot of people have been using Kiwi for that, building games for Android, mainly for prototyping purposes. In terms of performance, it actually depends on what you want to do. Yeah, one of the problems with Kiwi is that because it tries to be cross-platform, so the API is very generic, very general. So things that are Android specific or iOS specific, you might not be able to use yet. Things like push notifications on Android, what are those? So any platform specific stuff you can use. But on general things like displaying button, touchscreen, scroll, most of it is usable. The only problem that I find with Kiwi is that the VJ set is idle. So you really need to work that. Yeah, but as you can see, right, the whole thing is scriptable. So like this whole game right, is actually a Kiwi interface, right? So you can actually put in your own images. It's a lot of images work. So instead of dropping widgets, right, you just have to put in images and you just have to float them around. Just exactly as how we used to build applications like 10 years ago, instead of having all these nice cool things. Yeah, so if you want to compare development between native and Kiwi, what I would suggest is that if you really want it to look nice, go for native. But if you want something that is quick and usable, things like this, like for example, what we have just now is just a catalog or a list of products. We don't really need to have a lot of native functions of that. Basically just have a beautiful background and just style your buttons, you can have a very good native interface already. Until it fails, then you can go to the natives. So a lot of time, I think Kiwi is just good enough, especially for, let's say, a commercial or let's say a corporate products. No corporate, sometimes they don't care if it's nice enough, just want it to be working. Yeah, so Kiwi is very awesome for that. Right. Any more questions? Okay, that's it.
Okay. So thank you very much. Prototyping. So thank you very much. So the next session will be building a scalable Python gRPC service using Kubernetes by DM Lewis. So let's put our hands together in welcoming this gentleman.
To him?
No.
Yeah, only I need a mic, I know. Alright, let's start with stuff we all get, also known as swag. So here goes. So here's two things we need to know. One, we are a poor group, so we don't have stuff. We can't give you that much, and all stuff from our sponsor, and we are not opera, so you cannot give your card. So, and no, I will not do an opera impression. No! So, but everybody get a gift. Alright? So what do you people get? First you get oh yeah, so thanks already, we actually get discount code. So this is a discount code, you got 30 seconds to actually take photo of it. Now, the code can be used for already shop, you can actually use it for books, physical books, e-books, and videos. So with the current economy, you will need it. So yes. How much is the discount? Oh yeah, so physical book you get 40% and 50% for digital product, including videos and e-books. Good, and I said everybody took their photo. Next. So everyone in this room you actually get.
Yay.
I hope you guys don't regret for not being our speaker because you actually get twice as much of the credit. But the email can only come much later. So if we're not send the email, AWS will send it. So take a while. And finally, there's stuff that not everyone will get. 5 of them.
Snag.
So, thanks to JetBrains, we actually get Pycon license. So who's the subline user here? Sorry. So they stop for you. Okay, so to actually run our
Drawbot.
run our lucky draw, we have attempted to use a Python script to automate our process. You can only do one thing, draw. So we shall begin.
It's very good lah. Very random.
Yeah, the project I write from scratch, and not nobody actually got preferential treatment. All right, let's draw. Okay, so the first name is Muhammad Ali. Please come down.
Right.
Calling once, calling twice, and it's done. Next. So the next winner is Jaya Silan.
More chances for you.
And Imran Arifin.
Imran Arifin.
He's not here. Pati. Yeah, because FYI, we will actually email the code, license code to you people. It will take some time. So for anyone that never used Pycon before, it's awesome, by the way. So
Yeah, the company one. Sponsors coming.
Okay, representative from OnApp can come down. I know one or two you guys should hear. The people, you guys. Yeah.
Pycon.
I will kick you guys out for not using a real name. Next, we have Mr. Eric Kang.
Once.
Call it twice, and it's gone.
Okay. Yes.
And you can do it with the license anywhere you want. You can give it to your friend and family. Yes. So we can stop here.
Two more.
Yes, two more licenses coming up. And
there's so many.
Yes. And okay, Mr. Faris, Zaidi, Muhammad. Yours. We have winner Ali Kohan. Call it once. Call it twice. It's gone.
Okay, next.
And Mr. Tati. Anyone among you guys that don't use any IDE? I want the license.
Can you guys come up to the stage?
Okay, we won't be giving you the code right now, but we'll email you the code as soon as possible. So just take a photo, show yourself, and we will email. Yes, it does get stored. Oh, it's good.
Okay, thank you.
Wait, let the lady.
Oh, yeah.
Nah, let's enjoy yourself. Okay, and with that, we conclude of giving the stuff that we all don't get. All right, I leave the rest of the session to Iqbal. Thank you very much.
go. Okay. Right, Russ, how are you? Glad you stayed with us until the end. So, my name is Bob, by the way. Yeah, let's talk about the conference and some numbers that I'd like to share with you. Our first major Pycon. Right. These are some numbers that I've taken from the data that you gave us when you signed up. It tells us about what. There's also some other stuff which I've taken during our meetings, which I'll share to you. Hopefully with this you'll understand and appreciate more about the things that Pycon might stand to see. About the conference itself, we sold 146 tickets, total 146 tickets, which is around twice what we did last year in our Pycon, which was around 70. We had a one-track, one-day conference at iTrain. So they were kind enough to lend us their rooms to use. And we had 18 speakers total, with 21 sessions, and 8 sponsors, which were kind enough to give us cash, presents, Pycon code, discount code for riding. And in preparing for the conference, for some time, this week we had a once-a-week panel committee, which spanned 21 weeks, a total of 21 calls. Average 3 people joined each of the calls, which is basically me, Swimming, and Russ. So a total of within 31 calls, we used up around 63 man hours. And on top of that, an average of around 0.5 man hours per week. For 21 weeks to actually work on organizing the Pycon, equals to 210 hours, which is basically around a month of, if you work full time, it will take you around a month. And then we were working for like 3 people. Now, why I'm sharing this with you is that we would like to aim for a bigger, a better, and a faster Pycon for Malaysia. I've been to a few Pycons myself. The first one I went was in Singapore. I think it was in 2010 or 11? 2011. That was the first Pycon, Asia Pacific Pycon. And then they had it in JP, which I also involved in organizing. Then they moved to Taiwan, and they're going to do it in Korea next year. So, and each of these locales, they have their own local Pycon, which is not APAC. But after going through all these cities, I've come to realize that KL is a great city for Pycon. It's centralized within Southeast Asia. You can get to Kuala Lumpur basically within 3-4 hours from basically anywhere around East Asia. It is inexpensive, unlike SG, Tokyo, right? Even Taiwan and Korea. We understand the region of English.
Oh, that's true.
We have great food, obviously, and I have a feeling that we are ready here in Kuala Lumpur to make great Pycon and great Python history. Because we've never had one before. So, Marcus, as you mentioned, we know that he was happy that we finally gotten somewhere where he actually tried to do it, but he couldn't because of life gets in the way, things happen. So the point of all this is for me, for us, you guys, and one of you who is actually taking your time off from your valuable weekend to join us and organize Pycon Mile. Right. Now that's about us, and now this is about you. Okay, so there are certain data that you took when you registered, and one of them is actually when you actually purchase this ticket. There's nothing, no seriousness about this. It's just something to share. So as you can see, this is a big. There are like 5 tickets bought, and then we started selling in May
and then closed at around July. So as you can see, no one really cared at the start, and then suddenly it's Python at the end. And this is very Malaysian. Is someone else going? If no one is going, I'm not going. Then suddenly, oh, the guy is going, I have to go, And then, after we close tickets, because we need to make sure the caterers are here with enough food, t-shirts are available and stuff, people started sending us emails, say, hey, can I join now? But tickets are closed, can you make me an exception, which unfortunately we can't, because we only have 3 people and we can't handle exceptions very well. So, if Python does exception better than this. Yeah, and you also told us where you're from. Basically, are you from within KL or are you from outside? And interestingly, well, quite a number of you are actually from outside of KL, so that's like 33%. And I think it makes sense that most of you are actually in KL, but the fact that more than a quarter is from outside of KL shows us that there is actually interest and there is actually effort from the developer community or use Python in Malaysia to actually come and participate in the Pycon event. And we are very happy that you are here. So there's even people from JP, from SG, Bangkok from SG. We have Cik Ugi from Singapore. Dylan came all the way from BKK, and then Mark-Liz, they all came from outside of Malaysia. Can I have a thank you very much, really appreciate it. And you also told us how long have you been using Python, which is I think one of the most interesting data that we have. 80% of you knows Python for less than 2 years. So one of the main aims that we have in Python is actually to reach out to groups, communities which are still new to Python. It doesn't make sense to have like people who use Python for 5 to 10 years and all of them come to Python. It's not fun, So this is actually the right people that would like to come and join us again when we do it. Right, so within this group of people that's 2 years learning Python for less than 2 years, are you currently working or are you still studying? And we found out that 72% people are actually working somewhere, right? While a more smaller percentage, less than 20%, is out of student. So what I would like to tell you guys and girls, ladies and gentlemen, is to bring back Python and charm the office. Right?
What? The other way around?
Well, you use Python to. No, you can't use the office to charm Python. You need Python to charm the office, right? So whatever works. The point here is as long as your office uses Python more, right? It's a great language. Mark, in his keynote, he has learned, 20 languages, Mark? Right? And he keeps coming back to the snake. He keeps coming back to Python. So the Python has charmed Mark, and I'm sure you can charm your office with the Python. Very charming person. A very charming student. And okay, and this is just some side notes. There's also a place when you register what you want to tell us, right? It says free space, you can just put in any kind of tag. So I like to share some, which I think is interesting. There's this part where people write their hopes and dreams, and this is one guy or girl. I'm not sure of the gender, so I put primarily in Python. It's verbatim, right? So it's not my fault. Maybe I can help you guys in workshop or give you some thoughts. Great, we are waiting for you. We are always available on Twitter, on Facebook, or anything. I will even. I think we have an email. We'll contact you later on. We do need people to give workshop and give talks. And there's a few number that says hoping to become a good at programming.
That's a good thing for you to aim for. More power street, please. Right? Understandable. We can work on that. I prefer workshops more than 1 day. Thanks. Yeah, okay. We can try. Looking forward to meeting Pythonistas in Malaysia. I hope you did. I'm anxious and excited to learn new things. Yes, yeah. On all we are anxious and excited to learn new things. There's also this part which doesn't fall into any certain categories, so I just say, just put it under just saying no. No. None. Which is actually a reserved keyword in Python. That's good. No thanks. I'm Linux enthusiast working on web development. Okay. My phone number. There is actually an actual phone number there, but for privacy reasons, okay. I purchased tickets for others too. Right? Yeah. I'm from GDG. Oh, I know. You guys know this person. Swimming to me, I will get. I actually know who this is. Thank you, sir. I'm part-time student working, having experience in web development but not in Python language. Okay, great. I cannot code for nuts. Right. So what do you code for? Okay. Right. Okay. This is my favorite part. Professions of love and gratitude. Python. Yeah. I'm sure that I love for this girl loves Python. Python rulers. I love Python. Me too. I love unfortunately, I can't recall whether this person is a local or foreigner, whether it's a male or female or neither. So, anyway, whatever works to me, we are happy for you. Definitely not me. But I still like you. I don't really love you. And this is my favorite thank you, which I think every one of us from the people running Pycon live for 15 likes the most. And with that, we'd like to thank first our sponsors, which have been very kindful. Without them, there will be less food. We'll be talking under a tree in the middle of a field. Right? Without them, this won't happen. So, thank you to our sponsors. And a very special thank you to the Faculty of Computer Science and Information Technology. I would like all of the volunteer staff, all the staff, to please come up to stage here so that we can see So, I'd like to thank you guys for your valuable weekend. Thank you guys for the weekend. Okay, and finally, last but not least, we would like to thank you for coming to Python. See you next year at Pycon 2016, and which swimming has volunteered to chair.
Me and my big mouth.
Do you have anything you want to let us?
Alright. Okay, next year. Confession time. I have no idea what I'm going to do next year. Okay, but next year we try to get the same place, same menu. We hope to make things, definitely make things better. any opinion that you have for this year, show it on the Facebook group. You don't know where the Facebook group is, show it on Twitter with the Twitter handle. I will read it, I will take consideration for next year. As long as I remember it, no guarantee. Hopefully, I hope you people actually learn something, and more importantly, I hope you people actually learn something, use it and share it back next year for the next conference. So I hope to see you people next year. Thank you very much.
Alright, there goes swimming. So we look forward to see you, guys and girls, ladies and gentlemen, or in between, whatever you are. Yeah, dogs is also fine. It's really okay. So, right, hope to see you again next year. Hopefully, in the same venue, we try to make it happen. I'll be also helping out swimming, but more or less detailed way. And next will be our photo session. And we'll be outside. Okay, so we'll have a group whole photo session in the front entrance. Okay, thank you everyone.
That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels. That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.